All right, everybody, we'll get started. We won't have to listen to me very long. I'm going to hand this over to Guillermo, but some of the logistics. Thanks, everybody, for coming. We have people online as well in the classroom. So if we pause for questions, it's usually online, which is great. If you have questions, just raise your hand here. Make sure you speak up loud so people remotely can hear the question. We'll try to repeat it if we can. Restroom is right outside this hallway. There's a break room. If you go out the hallway, take a right and all the way down to your left. Parking passes, I will get those for everybody. I'm just waiting for the person to come in that has those, but you will have those, so don't worry about it. And next break, I don't know, probably have a break here in an hour, hour and a half. Make sure you sign in with me or Daniel in the back. Daniel's raised his hand right back there. Before I hand it over to Guillermo, any questions for me? All right. Get started then. Screen share for you. Yeah. Yep. If you get it back, I think you're good.
Okay, good morning. My name is Guillermo. I will present to you. This year, we decided to make a small class on Python for scientific computing. So this kind of approach is slightly different from the kind of things that you probably typically see on internet. For this kind of class. It's not oriented for industry or crunching things with Twitter, Facebook, or things like that, or doing silly things with animal names and house pricings or things like that. And this is mostly focused on crunching numbers. And dealing with data numbers that somehow are related with science. Some exercises, I have to lower that expectation a little bit for simple things. But this is my goal, is focus this for scientific computing. Let me, before let me show you this figure. By the way, this, I don't know if it's visible. You can open this. I didn't create actually this time the QR code, but the address is right there. Probably, I don't know if it's visible. Let's see if I can make it visible somehow. I don't know. But it will be there. It will be there. The last presentations from previous years are still on GitHub. They are accessible. They are web page for this. I never delete those things. So let's start with this. To motivate why to learn Python, if you are used to a different language for your scientific research, why to learn a new language? And my point is that if you do not know any language, any programming language, probably the first language that you should learn is this one. It's the only language that you want to learn, except in some very specific cases. For most types of research, in general, is Python. And if you see this plot, this is not exclusively for scientific purposes, but in general, Python is right here, top of the corner. And this is a plot where it's ranking popularity of projects on GitHub. So a repository of software and programs projects and things like that. And this one is ranking the popularity based on the number of questions posed in this place, in Stack Overflow, a popular website for people asking questions about how I do this, how I do that. So, so if you see this plot from the x-axis, you will realize that a lot of projects, tiny, big, medium, a lot of them are written in Python. Interpret this other axis is slightly more complicated because it means that many people is asking questions about that, or the topic is so hard that many people ask questions about that. So that could be, for example, the case of CUDA, with not many projects include that language, but well, that extension that C, but many people make questions about it. So anyway, this just to motivate why Python. Here you can see some other languages that are in use in scientific computing. MATLAB is around here. C is around here. Fortran is around here. Those are the main languages for scientific computing. So let's go back and present what the landscape that we will offer you in these 2 days. We will work with Python. We will be working with the Python 3 something. We are moving away from the Python 2, and the idea is that by the end of this year, Python 2 something will not be supported anymore, at least not officially. So there is no point to teach you about Python 2. I will mention briefly this a couple of differences between one and another, but the focus will be Python 3. So I expect you to, if you are working on your computer, to have Python 3 on that computer. We will be offering you an access to a virtual machine that is running everything that we need and on a Jupyter notebook, so everything will be fine. But I will, during this introductory time, I will show you different ways of getting this Python for you when you leave this class. So here, at some point, I will tell you to execute this line. This line contains all the data, the notebooks actually, so you can follow the notebook if you like, and the data needed for the exercise. Another thing is that I will, different from the last week, I will present something kind of like in the slides. I know no one who have learned anything just looking at slides. The only way to learn something is when you actually put into the effort of doing exercises and trying to figure it out. What is the meaning of all that text that was presented quickly for you during the exposition? So a lot of the time will be exercises. I will not be talking, you will be doing things here or remotely. So let's see different ways of getting this. This is the simplest, and that's what I expect you to use if you don't have a better idea, is using the Jupyter Hub that Nate created on this service, Jetstream. Basically, it looks like this. You should have an account. So he will give you some usernames.
You don't need the password on the sheet, just need the username.
You saw that question? Or
What was that?
I saw something. For,
They probably just sent it to you. I didn't get it.
okay.
Make sure to tell them on there to send it to everyone when they're chatting.
Okay. Sure.
And we messaged on the chat to say, yeah, send it.
Okay.
Yeah, be careful minimizing. Don't worry about the chat. We'll take care of it.
Okay. So this is one way. This is the way we will use.
Sir, real quick, you want to go ahead and log in? Oops.
So you, when you start, and I put this on here on the documentation, so you will, you can follow this. So basically, what we created was a virtual machine somewhere in Indiana. This virtual machine contains Jupyter Hub, that is a Python environment from a graphic user interface nicely where you can access it without any issue.
So please use the username that you're given either in the paper I sent you during class or in the PDF. Your password for everybody is capitalized HPC 2019.
Is there an underscore between those two? No.
So the password, I will put it here. I put it on the username, but that's the actual password for all of you. So the idea is that you will get different accounts, but everybody can work on that machine. And this is probably the simplest way of working in Python. But I will show you some other ways. So what we will do is,
For class, though, we want everybody to use this.
yeah, let's say, if you don't have a very good reason for not doing this, and you know Python, and you feel comfortable, and you want to do it on your computer, and you want to, it's perfectly fine. But let's say you are kind of on your own. If you don't know anything about this and you want something simple, graphic user interface, nicely, this is the way. So one thing that you can do now is to, if you are doing this way, is to go here into New and go into Terminal and execute this command. I will keep it like that so you can close.
It's on the training page.
It's on the training page. But, I can go to the training page and then maybe that's another way. So I put it here. This is the command that you have to execute on right there. So I'm here on this terminal. Here, write this.
You zoom in on the terminal screen.
The terminal screen, I will close it and I will reopen it. Here, terminal.
Yeah, you zoom in. I can't. It's hard to see.
I don't know if you can zoom.
Control Shift.
Oh yeah, zoom. Okay. This is the terminal. So I will give you some time to get it done, and I will keep here. So maybe I copy. This is what you can do here.
Should have copy and paste.
Paste. So this is the command. I will keep it like this so you can execute this. And this is what happens. You click, hit enter. By the way, the idea is this morning we will be dealing with Python as a language, just the syntax, all the stuff. This afternoon will be about the Python standard library. I select a few of those modules, those that I found on my personal experience the most useful for scientific computing, but that's for my kind of research. And so the selection of modules in that extensive list is kind of personal. So I will present those. Show them what you can do with them. And tomorrow I will be showing you a few packages, the basic ones for scientific computing. That will be NumPy, SciPy, Matplotlib, Pandas, and Cython. Those are the topics for tomorrow. So I hope you got this, all of you got this, but I will, if not, who got this done? Raise your hand if everything. So not all the hands are up, so I will give you some minutes. We have time. I set up at least 1 hour just to get this done. And I can go and show you different things and give you time to, so those who already got this done don't have something to learn. Let me see, in the meantime. So I'll show you the first way. It's Jupyter Hub. Another way, for those who have an account on Spruce and want something like this after the training, this is one way of getting it on Spruce. It involves more commands. It's the kind of, this is what it's the advanced way. So I don't expect you to follow this if you are just learning this from the very beginning. So that's why we select the virtual machine. It's much easier from the virtual machine. But with the Spruce, it will be like this, to get something like similar to what you saw. You have to execute this command on your computer. If you are using Windows with mobile term or something. If you are using Linux, Mac, remember for Mac you need this package. No, you don't actually need this. So you execute this command. What you are doing is basically redirecting this port to your local host. So it's basically making a connection such a way that you can communicate directly with the machine, with the cluster on your browser. So this is the first thing. This is first obstacle, if you like. After that, you have to source this for Conda, for getting access to Conda. And we showed that last week, but not all of you attend the previous workshop. Just execute this and you get Conda. After you get Conda, you execute this to open a Jupyter notebook on this port. And as you have done that, as soon as you have done that, you will get something like this. And you copy and paste this on your browser and you get it exactly the same. You get an environment, and after that you will get exactly the same Jupyter Hub on a cluster. Yes?
Direct source?
Yes. This is the, if you have an account of Spruce and you have a problem. So this source.
Yeah, but I didn't have.
Oh, I forgot something in the middle of this. Conda activate Jupyter. Conda, I forgot something here. There is something here. Activate Jupyter notebook and never put the command. So Conda activate Jupyter. That I forgot that. To get access into that Conda environment, I create a Conda environment or using the Intel channel, and after that you can execute Jupyter notebook. You got it? Okay. So, so this is one way. As you see, that involves, and I just skip one command, unfortunately. 1, 2, plus the conda activate, plus this, plus open your browser and copy and paste this. Those are like 5 steps that you have to follow in order to get exactly the same that you are getting right now on the virtual machine. So that's one way. On your own computer. So you want to do it on your own, or you want to start using Python for you. My recommendation is forget about Python 2. You need it for something, and that has not been ported to Python 3. Forget it. It will at some point you will not be able to work with that code or whatever. So work with Python 3. That's the first advice. There are several ways to get Python working on your computer, even if you are using Windows. One way is to install Anaconda, and this is the place, Anaconda. This is one. They have for Windows, for Mac. It's very easy to download. It's very easy to install. It's kind of low. It's kind of big, but it will give you a full environment to work with. Another way is if you know this and you just want, you don't want the niceties of a graphic user interface, you can just get an SSH client, and as we showed last week, get into the cluster and start operating with the IPython terminal or creating the scripts and running scripts. It's perfectly fine. That's another way. So, who have downloaded, got into the cluster and execute this, everything is fine. Raise your hand if you've done that. Or you are still.
I'm on that. Do we need to go?
And now you hit enter. You hit enter. And you got this, all those messages. It's okay. Okay. So I imagine that everybody is okay on this. So we have the code. Okay. So as I show you, there are good reasons for using Python. There are other languages here that are also interesting, but they are rather new, so they are gaining track on this. But Julia is a promising language too. R should be around here. R, I forgot to mention those 2 languages for scientific computing. And not right now, but with a different setup, it's also possible to use Jupyter with those different languages. So you can use Jupyter, and instead of executing this with Python, you can execute things with R, or you can execute things with Julia. So they have those kernels, that's how they are called, kernels for Jupyter. It was originally created for Python, but now it's for more languages. Let's see, what else? There are several ways of working with Python, and this is one of the unique characteristics of Python, due to the way the language was created and how it evolved. There are several circumstances or several ways of working with Python. One is interactive computing, and that's probably the best way for learning the language for most part. That's what I am proposing you to follow. But also during actual research, it's a good practice to explore the data, explore what you have with your numbers. And for that, the best way is actually doing and sitting on an environment like this and start exploring what the data, the numbers tell you. So when you start gaining knowledge, confidence on what that data is produced, is giving to you, is telling you, in order to tell a story that you will put in your paper, you start writing the scripts. scripts that will automatize those procedures, creating the plots, doing all those. And after running those, hello. You good? Okay. Scripts. And the good thing is that with Python and those notebooks, you can start with interactive computing and start creating scripts. So we are following the path here. As those scripts evolve and becoming more complex, by the way, I understand scripts as small pieces of code that are typically dirty, but they do the job that they have to do. And one single file, 2 files, that's what I understand as a script. It could have up to 500 lines of code, 1,000 lines of code, but keep it like that. It's just 1 or 2 files, dirty, not much structure, only you know how that thing works. Probably not very well documented. There's something for getting the job done. Things evolve and you start putting the structure in those scripts. And you start creating programs, creating libraries. So I will show you a little bit how to achieve that. But basically, you can move into these 2 options. Creating programs that execute large, different operations on that, on a structure, on a topic, on an area, or libraries that are meant to be used by other programs in order to create more complex developments. And 2 kinds of final applications for final use. And you can create all those with Python too. One is graphic user interface applications. So the kind of applications that people see typically on Windows, when you have buttons and you click and click and click and do things. Or web applications, where you can see all the structure of your data and you can start moving slides and different web elements in order to manipulate data from a browser. All those things you can do with Python. And that's kind of atypical because with hard languages, C, Fortran, you typically are around here. You can create web applications, libraries, programs, but you cannot execute interactive. And you can create something like scripts, but they are far more complicated to create, and they are not so flexible at the end of the day. Or you can create scripts with shell scripting, and we showed a little bit of that last week, but you cannot expect to create complex graphic applications with shell scripting. You cannot do that. And you can do interactive computing with other languages like MATLAB, but you cannot go too far because that language is very specific. It's very vertical in the so you reach some limitations when you start creating graphic applications, even if you can. With MATLAB, you can create buttons and things like that, but it's not so flexible. But with Python, you can do all of that. So as I told you, we will avoid Python 2. Forget about Python 2. For you, most of you are young, so you imagine that thing never exists. And tomorrow, we will talk about these extra packages that are specific for scientific computing. So we will talk about them tomorrow. I will try to avoid as much as possible, even if I know that it's not the right solution right now for doing some things. I will do it with list. I will do it in the bad way. So in that way, I will separate. I'm trying to separate this, to put that in your mind. So what is the language? What is the standard library? And all those extra packages that exist. And I picked just 5 of them for doing scientific computing. So I will try not to mix that. It was a pain for a couple of things, but anyway. So again, if you are working and you don't want to do this in a graphic user interface, there is another way. From the cluster is loading these kind of modules, and we showed that last week. And you get Python 3.7 up and running, and you can execute IPython, the IPython terminal for you. By the way, the IPython terminal looks like this. For those who, the Python terminal is like this. It's a terminal. You execute commands, and you can use this and get results. But on the terminal, typically you cannot create plots, or you can create them, but they should pop up as separate windows, and something that you cannot do in a virtual terminal like this. But for you to know that you can load those things. And we have this option on Spruce for Python 3.7, and we have this option here for with the Intel distribution of Python, and check that you are running the right version of Python. This is one way of knowing the version of Python that you have. That's actually something that I can do here. Let me see. Because this is important. Okay. Typically, operating systems comes with Python too, because they use it for things that have been there for years. So it's common on Linux environments to have both versions. And sometimes Python refers to Python 3, but most of the time Python is just the Python 2 version of that, and Python 3 is the Python 3 version. So let's see what we have here on this virtual machine. I don't have any idea of what I will get. 3.6. So in some other, for example, on the Spruce, if you execute this, you get the old version of Python, so 2 point something, except if you load newer model. But just to be sure, use this one, Python 3 version, Python 3 dash version. That's the best way of being sure that you have, first, that you have Python 3 and which version of Python 3 you have. And if you are using Python 3.6, 3.7, you are probably fine for all of this. I tested with Python 3.6. All my notebooks, I run it on Python 3.6. I run it on Python 3.7 on different machines, or where I have those, and they work perfectly fine. There are a few differences, not with the language, but this afternoon, with a couple of things that have changed with Python 3.4, 3.5, and a couple of those modules that we present. Particularly the subprocess module. They have received some changes on that. But if you get 3.6 something, you are fine. Don't worry about it. From here, you can start exploring, and I will do that in a minute. Let's do that right now. You can click here, go to this, and open a new notebook, Python 3. You will get a new tab on your browser, and you get something like this. So I will show you those things to differentiate what kind of things are Python and what kind of things are IPython, because those two things could be confusing because they are you write those things on the same line. And with Python, you can do things like this. This is that. You just type the numbers, and to execute that line, you hit Shift Enter. This is how you work on this. On the contrary, here, when you just hit Enter, you execute. This is how that works on the terminal, in the IPython terminal. This is how this works on the IPython notebook or the Jupyter notebook we're running on Python kernel. By the way, it used to be called IPython notebook. So if you search on internet, you will find something like IPython notebooks. This was originally created inside the IPython project and was separated at some point. Some other things. In this kind of environment, in the IPython, Jupyter notebooks, you can do things that you cannot do normally in Python. It's something like that. Execute commands from the shell. Again, this is not Python. This is something that you are doing with IPython, and exactly the same that you can do here. So you can execute a few commands from the command line, the Linux command line, inside the environment, and they accept. In particular, you can create, let's see this one. You cannot do this, and this is a command that you saw this, but you can execute this. If you put the question, exclamation mark, it will execute that command. This is not Python. This is the notebook that allows me to do this. So differentiate those things. So I can get this. So those are on things like this. This is actually very good if you like to keep this for your records, let's say. It's actually a really good idea. Execute this. With this percentage at the very beginning. This is not Python. This is IPython notebook. We're going to execute it here. The IPython terminal or the notebook. What I'm doing here is storing every command that you have here on a file. This is probably not so interesting here on the Jupyter notebook because you can save this as an IPython notebook, but this is very good here when you are working on an IPython terminal. Why? Because you are storing all your mistakes, and that's exactly what the kind of things that you need for learning. Keep all your mistakes and the good things, and later you prune all those things that fail and all your mistakes and all those, you document those, and you keep, and you start building a script. So that's how you move from writing interactive computing into scripts. You start exploring, storing everything, and after that, starting cleaning your ideas and getting what it will become a good script. Okay. What are another comment? This is, again, this is not Python. I start with the non-Python things, that the history. You can execute this. Again, this is not Python. This is IPython. This is the Jupyter notebook that allow you to do this. With Jupyter notebooks, you can actually create nice things, and I will show you. And you can start writing like actual notebook, and you can here convert those blocks into different non-executable blocks of text, and you start getting a structure on this. So that's how we create those notebooks. And you can put equations, and I will not show that, but you can put equations, and you can create actually a complete notebook for training purposes. Okay. Let me see what I can show you. Okay, what is this? Okay, no, let's do this just because it's a good exercise. don't worry about not understanding exactly what all those commands, but just follow the string. You have an question? Yes.
So if I click today and then I would log in tomorrow with in the same account, I could still recall the history from.
Yes, from the IPython terminal. Yes, yes. They keep the history of all those commands, and I actually use it. On the Jupyter Notebook. What you should be doing is something like this, storing this here, clicking here, and actually we'll put my name. So I will explore, they will explore one. So I will put a name here. I click here, and you click and you change the name. Try to do that. Change the name. This is your notebook for exploration, and this is actually what I would like you to use when you start doing the exercises. And you will have some time for doing the exercises, and I hope interesting. Nothing silly like cat, dog, and giraffe. No, I will not do that. I hope with some interesting things later. So rename this, and you keep your notebook, and you store it here. You click save, and you keep your notebook. This is what it is. It's a notebook. So you can start putting a structure on these chapters where I am cleaning my data. So this is my, I got this database. Okay, cleaning my data, removing all the missing data. Okay, now I am getting some plots for getting basic statistics about gender or age, some histograms about age distribution, the geographical location. So I will start exploring my data. So now I am working on getting some operations with other libraries that will show tomorrow, and start getting information from the data. And you put that in sections, subsections, and you put it that in an organized way, such a that you can re-execute the whole notebook, and everything should be fine. So those things, again, starting with this, those are not Python. This is not Python language. This is not Python. This is actually shell. Send it through the Jupyter Notebook. This is Python.
So percents are IPython.
All those percents are IPython, and they are interpreted exactly the same here and here. By the way, I can put here the history. Those. And there are several, so I'm not mentioning all of them. There's just 2 or 3, just for you to get the distinction between those.
When you type this Python,
when you good question, good question. Let me see if I can do this here. I will create a new terminal here. Yeah, yes. There is another Python interpreter, Python 3, and it's this. And this is the pure Python interpreter. So it's something that I never use for scientific computing for several reasons. First, doesn't store the history. Second, I can execute, for those silly things. But you can go back and things like that. But I cannot start doing complex things with this. And okay, and also they start putting those silly dots in front of me. After that, I cannot. Well, I can, but it's not the best way of working. Yeah, and it's not indenting properly. It's a mess. It's a mess. So it's not good for me, for scientific computing. This is not the way I like it. The IPython notebook is perfect. It was created for that. It was created for doing science, and the people who create from my country actually lives in here for many years in Lebanon. And he created this, and he created for actually doing research in nuclear physics. Okay, let's go back here. So this is called the dashboard. And you saw that I store my notebook with this name. So you should see this on your dashboard. You have your collection of notebooks, right? And here we have the collection of the notebook that I exposed to you today, that we will be working, this and this. There are more, but they are not visible right now. Let me see what else we have. This is not. Okay. Yeah. So this is the idea. Follow this as a recipe. It's just to motivate, it's just to explore. This is Python. Okay, this is not Python. Yeah, to show you another. This is not Python. This is the IPython, the notebook, and I'm telling the notebook I would like to see the images with my notebook, inserted in my notebook, instead of popping images out. You can select what do you want to get on the image. This is Python. I'm importing the module that we will see tomorrow. This is Python. Another thing, another nice thing from that, that's why another thing that I don't like from the original interpreter is that I cannot complete. You write this, example like this, and I hit tab, and it completes the module. It searches the modules available, and it completes the module for me. And it's also able to show me different alternatives for complete the classes, methods, variable, constants, all that. Everything that I can do from there, I can complete it. And this is one of the nice things in the IPython notebook. PyPlot. Execute this. Shift enter. So first line, this is not Python. This is IPython, the notebook. This is the notebook, the magic. This is called a magic actually. This is Python. I'm importing something that allow me to deal with numbers. And this is a module for plotting things, from getting some images. And now execute this. This is just motivation. I don't expect you to understand exactly what I'm doing. By the way, you can start playing with this, put more dots, and you can, let me see, you can re-execute this. You can introduce changes on the notebook and hit enter, and you can play with them. So this the first letter, by the way, is the color, so you can play with that blue. And you can put different symbols here. This is one of them. Triangles, and things like that. So, and you can change the number of points.
If you do shift enter, you run the whole notebook.
No, you run this particular box. You can click here, and you can clear the output, and or you can restart. So it kills the kernel and restores the kernel and executes the whole node. You can do that from the node. So this is actually a good thing. You can Sometimes you would like to do this, and that avoids that small line that appears without.
I have a question.
Yes.
If you, when you're typing in, let's say that you send it off, executed, mistype, is there a function where you can recall and fix it?
Yeah, sure. For example, I type this and execute this, and there's no, that doesn't exist. This is not variable like that. So you can, what I would like to do is to create a variable instead of this.
Or you just go back?
And go back, change it, and re-execute. So this is interactive computing. This is making mistakes, fixing mistakes, learning. If you don't make mistakes, you never learn. So mistakes is the most important thing. Place it in the entire life. Right?
You go a little bit up.
And you can go up, yes. So those are the 3 commands. I'm going slow. I'm trying to make the separation between what is the notebook, what is Python, and we are not entering the details, too much into the details of the language right now. I want, let's say, a soft landing into this language.
How to create a new cell? Suppose I want to put the command before matplotlib.
Okay, you can do several things. Let's say you can introduce comments in the Python way inside the so this is not interpreted by. This is the Python kind of the way of getting commentaries on the language. But also you can create new tabs, insert tabs before and after this one. Another thing, when you see this blue line here, you are in command mode. When you hit here, it becomes green and you are in the input mode. I think it's called input mode. So there is a distinction on that. So command mode, input mode. When you're in command mode, when it's blue, you can hit A and you create a new box on top of that. When you are in command mode and you hit B, you create a new one below. If you don't remember those things, you can just hit here, insert cell above, insert cell below. If you want to know those letters, you can hit here, and here is the shortcuts in command mode. And in it's called edit mode. Right? So with that, you can start speeding up the execution. For example, I would like to make a subtitle. So this is command mode. Again, this is not Python. This is a notebook, the notebook. And this is subtitle. But this is an execution. So if I execute it, this is a comment. Because this is, it looks like a comment. But what I'm writing here is something called Markdown. Markdown. So I can convert it into Markdown here. And it becomes a subtitle when I execute it. It's a subtitle. Or I can, in a different way, if it's in command mode, I can convert it into Markdown with escape N. It's in the list of keywords for that, and it will become a subtitle. So the idea is what I suggest students that I help with their thesis is create notebooks and make it such that you get this kind of plots ready for publication. We will see this, how do you adjust the different distances, the size of those fonts, because you should have them properly. It's very, I often see many papers where the fonts for those things is too tiny. It's too tiny. This is a big mistake. how you're supposed to read this. Or they put it in colors, everything different colors, but the same symbol. So you cannot, if you print this in black and white, and many people in many countries just print these things in black and white, how you can understand those plots if everything is just in black and white, and with the same symbols. So make those in such a way that you can reproduce your notebook, reproduce your results, get the figures ready for production, export them into PDF so that you can insert those directly into the journal. If someone complains about, the referees complain about some small detail, you can change the small details and recreate the whole thing instead of spending 3 weeks more doing all those changes just because the referee told you that the factor is slightly different. So do this. This saves you time in the long term. Let's go. Let's continue. So you create those plots. This is working. This is the IPython now. And with this understanding, we can move on and start learning the language. This is what we will be doing. By the way, there is another one. There is another that I will not show live. Is this IPython Qt console. It's basically the same thing, except because it pops a window where you can execute the commands and see the plots inside. It's very good when your connection to the system, or they don't have the Jupyter notebook available. All that you can do is doing this. So this is an alternative to work with. By the way, this is the IPython notebook. So now we are ready to start learning the language. So we are here. I hope you download this with on the terminal. So here on the dashboard, this is called the dashboard. You have this, the data for this, and this is the data for last week. And now I put here the data for this week. Here, click here. Click in the number 2, the Python syntax. I hope every one of you got this right. So let's close it. I will close it. I actually need to move this. So go back. By the way, if you have here on this tab here running, you can have actually multiple notebooks running at the same time. This is another thing. There is another one if you want to explore. It's not very suitable for the small screens, but if you have a nice screen, or you work with multiple screens, as I used to work with 3, 4 screens in front of me, like a broker, it's very good to have another one that is called Jupyter Lab, I think, Jupyter Lab. It allows you to have multiple, let me see if I can show you that. It's new, it's a new thing. Let's see, show you. It looks like this. I don't know if it's super visible. Well, it's something like this. So the good thing is that here you can have the different notebooks, the terminals, the tabs, and you can start working with different languages. Sometimes some things, for example, statistics, they work easier, or you are more comfortable doing those things in R instead of Python. So you can do some processing of some things in R and doing some other processing with Python or some other processing with Julia, and you can have all of them in one single environment with different languages, and you start moving your research forward with this. So this is another way. This is new. It's very good, but it consumes more space. So you need to have a bigger screen or more resolution on your terminal or on your monitor to get something like that. So, but here you can if something goes wrong, you can shut down some notebooks. And for example, I'm just keeping this, so we can close this one. So this one is not running right now. So what I ask you is to go here to the dashboard and hit here. Every one of you should be here. So in the next hour or maybe 30 minutes, I will see how fast I go with this. I will show you the syntax. I don't expect you to learn. I don't never know. I know anybody could learn just looking at the slides. So this is not for learning. This is just to get a landscape of what is there. So later, when the exercises, you start scrolling up and down, trying to figure out what you have to do to solve the puzzles. And I will keep this one, let's say, for exploration. So for extra exploration in case that I lose. So this one is my first notebook, just the basic, the syntax of the language. One of the nice things of Python is that allow you to create very compact code. Okay, this is as a motivation. This is a definition of a function in Python. We will see this in due time. All those functions are defined, but this is the definition of a function for an algorithm that is called quicksort, a very popular algorithm for people in computer science. Yes. How many lines? Like less than 10 lines, plus the execution. Anyway, a very similar algorithm. So the same algorithm implemented in C language looks like this. Just to give you an idea. So even if you are very comfortable programming in C, you have to type 2-3 times more to get the same thing. And with Python, just those lines. They include some things that we will see all those things basically. We will go. You will understand this function by the end of this session. My point is, Python is compact, and it's still very clear after you learn a little bit of it. So you can follow what is here, what is implemented on the quicksort. And if you see in Wikipedia the explanation of the quicksort and the pivot, the meaning of the pivot, and how that is recursively searching or sorting a list of values, you understand what is happening on that algorithm. Again, from inside. Now, I showed you a few minutes ago how to know the version of Python from outside. From inside, you have to import something that we will see this afternoon. But if you want to know, I forgot. It's because I killed. Yes, I killed this kernel. So you can see this. This is exactly what I show you here. Wow, I can re-execute it here. And now this is what. So my notebook is preserving the output that I set up when I execute it on my Mac these days. So this is what you should be getting on your virtual machine right now. By the way, you should be fine if you are working with 3.6, 3.7. For those things, it's a recent enough version. Numbers. Python is very flexible with how you define variables. You don't have to specify which kind of variable. Different from C. If you see C here, you have to say, okay, this is an integer. And n is an integer for the entire life of the scope of this variable. and you have to preserve that. If the variable is meant to contain a real number, you have to say from the very beginning, okay, this is a real number. In Python, you don't have to do that. That's one of the flexibilities of the language. That's one of the things that make the language slow. And we will see how we can solve that thing with Cython by the end of this workshop. So you can create a variable like this. Just you assign a value, and you can print. The first thing is showing you 3, and this is a function that tells you what kind of variable is this X right now, and you can change it. In the middle of the execution, you can change into a word, into a real number, but right now it's an integer. This is how you, in Python 3, print variables and execute some operations of them. So you can execute operations and the results can be printed directly. By the way, this operator changes from between languages. So you always need, and if you program in several languages, and I know like 10, 15 different programming languages, you might start getting a screw with those operators because you use one when you're supposed to be another. But for most part, okay, this is good to know that in Python. Python was defined like this. This kind of operator works. This comes from C. And this kind of operator works. So this is exactly the same, and I will probably should be working here. So I go to show you how I can start adding things. So I go into, you hit escape and you can go into comments, and I will create a box around here. And if you don't want, on the notebook, you don't have to put print every single time. I put it just to make an emphasis that I'm working with Python 3, because in Python 2, you don't have to put the parentheses. But in Python 3, you have to. That is one of the critical differences. And I will show some other difference between them. So you can do this. But you are not printing the variable. If you put like this, you are printing the variable. Something that you cannot do, and this is for those of you who are used to C++ or similar language, this doesn't exist. So you have to do it like this. A small difference, and it's good for you to know those. So the plus doesn't work. This one. Now I create a different variable, and I am associating a real number. It's what is in computer science called a floating point number. And I can operate with that and print the result. Okay, let me change this. True and false. You can create variables and associate values. And actually, you can do this small trick to associate true to the first variable, false to the second variable. This is often used in the language. And this variable right now receives the type of a boolean. It's true or false. Another type of variable. You can execute this kind of operators. By the way, this is another thing that changes between languages. In Python, it's like this. In some other languages, it's slash equal. So remember those things, that Python is like this. Words.
So the not,
This is not equal to.
so I can write not equal.
You can write, let me see if I can create, let me see, you can do things directly through. Or this. So remember, you can go here, go into command mode, and create a new box, and you can use your notebook. So you can keep your notebook, doing changes, explore. If something is not clear, create a new box there and check what happens if you change this, if you put this, if you add this. This is how you actually start learning. Strings. I will not put too much emphasis. Most books and tutorials put a lot of emphasis on this because those are for people in computer science. And for crunching number, yeah, you use this, but not so often. So you have this variable. You can create variables. And you can use the single quote and the double quote. If you remember, for those of you who attended the last session, in shell programming, those single and double quotes have different meanings. And the single quote is stronger than the double quote. In Python, they are at the same level. They're exactly the same. That allows you to put double quotes inside single quotes, and single quotes inside double quotes. So you can use them one or another and insert the other character in the.
Like parentheses.
Exactly. So let me show you this. So I can write this. Blah 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 blah, and put quote this. So I can use the single quote, or I can use here a single quote here if what I would like to use is the double quotes inside. This is a nice thing from Python to be able. Otherwise, if you are not able to do, you have to enter escape and the characters for playing with this. You can concatenate the variables of the same kind. So this is something that probably we will see in a minute. So here we are concatenating this variable that is on a string. It's what is called a word. It's in a string. And this is another string. It's an empty space. And this variable. And you can print the outcome of this. Maybe execute this. Yeah, because I make a mistake because I never execute the box, so it give me. I re-execute this and I come. Hello world. This is one way. This is actually the way that I typically use for writing to compose lines where I'm mixing numbers and characters and things like that. There are some other ways, and if you see, yes?
Can you go off that when you printed hello 5?
Oh, yes. Yeah, I forgot to mention this. The length. The length is a function that gives me how many characters are in, how many characters are in this line. So for example, if I define this, let me see, and let's see on here, length, spaces are counted, right? So it's counting the number of characters here, including the spaces. So it's not just the letters, it's all the length of this string of characters. This is the meaning of length for strings. So that's what I'm printing here. So it's printing this variable, the contents of this variable, that is hello. So this could be confusing. I don't need to put this, the variable like this. One thing is the variable, and I hope they put the, another is the content of the variable. And if I put more things like this, let me see. Oh yes, that's actually telling the number of characters. Yes, independent. No. Oh, yeah, exactly. I was not using the same. Okay. Let's go back here. This one. So I was telling you this, that this is how I compose lines where I'm mixing characters and numbers, something like that. And I will actually introduce a different one just to show you this. This is this is basically all that you need to know for composing this kind of characters. I define a variable with a floating point number, and here I'm printing a string. This is a string. The content of this variable at that moment is a string. This is another string. This is an integer. And this is a floating point number.
What's the percentage?
The percentage is indicating that I don't want to print S.
No, the other.
Or, the percentage is replace this string with the contents of this tuple. So we will see exactly the meaning of that. So the problem with learning in languages or learning many things is that sometimes you need to understand things that you only showed later in order to get the first thing. So learning is always a spiral. So you have to pass over some things like recipes and reread later in order to gain a new understanding. But so yeah, so I'm having here 4 values. I am basically associating this one here, this one, the second, the third one is this one, and the fourth one is this one. And it's okay if I code execute this, but it will recast this as a floating point number. This one will be truncating and recasting the value as an integer. This will definitely not work. So there is some flexibility, but to a logical point. Again, this is not the only way, but this is the best way. Right. Characters. Pay attention to this because some of the exercises are related to this. To play with this kind of variables or these functions. This is very common in object-oriented languages like C++, this dot notation. By this dot notation, I mean this is a function. It has parentheses, so it's a function. In object-oriented programming, it's called methods. The terminology changes a little bit. That is applied to an object. So S is like an object. There are some technicalities in why it's not exactly an object in the full extension of that, plus other languages will be. But I can operate with this with the dot operator and execute things. So I am defining a variable, and I will show you the effect of that. What happens when I capitalize. Look at this. This is pure lowercase. So the effect of capitalize is putting the first in capital letters And actually, it's much better if I work like this to see what's happening. This is sending the whole thing uppercase. This one is justifying. Here, I have to, in order to see this clearly, I have to make it bigger. So here, I am creating a 37 character string, and I am sending this hello world to the right. And here I'm sending the whole thing in the center. And here I'm replacing one character by another.
So the dot will always mean that after dot follows a function to assign to what is before
That
the
is
dot,
applying to what is behind
in front of the dot.
to what is the content of this. So this happens a lot in object-oriented programming. So you have an object, and you can start applying functions, what is called methods, to that object, or get properties from that object. We will see that a little bit. This is a very introductory. This goes probably the how those things are created goes for a more advanced. How you create objects where you can apply methods. I will mention it very briefly, but this probably lies beyond.
So what is it? A green is like a command for the Python, but what is inside parentheses?
It's an argument. It's an argument that some of those functions needs for doing things. For in particular, this one receives one argument. It's a number, and it's basically saying, okay, do you want to justify this word? So it will, how big you want the whole string? I wanted 37 characters. So it will be fully justify. There is another one, kind of execute it here on top. The equivalent of that is, but you will not see anything. The left justify. But this one still has 37 characters, spaces after this. So this is the left and right justification. Here, there are some number of spaces in such a way that here, the counting of this is actually the same. And here is the replacement. So I'm replacing this, every single place where this appears, with this set of characters. We will play with this during the exercise. So you know that it's here when you start dealing with the exercise. Search around here for the clues. Containers. So right now, which kind of variables we explore? We explore integers, strings, floating point numbers, or real numbers. I forgot one here. Let me see. There is that is important in scientific computing, and I forgot to mention that. Is complex. Complex. Oh, wait. What did you mark down? Ah, what am I down? Okay. This is how you create complex numbers, in case you need it. Or you can define it. What I'm doing here. This is a symbol to indicate the purely imaginary part. So 2 plus. This is how you create complex numbers. In case your research did with those things. So complex numbers, real numbers, integers. What else? Strings. Those are the basic elements of the language. But now we are talking about containers, so more complex structures. The first one is lists. learn how to use lists, know that for real purposes, for real scientific computing, try not to use them. They are very inefficient. So there are some other package, NumPy, for dealing with large amounts of numbers that is much better than this. So that's how you create lists. You can get individual elements of the list here, or change individual elements with this notation. You can put a new element after at the end of the list. So it's very flexible, but always in computing, in programming, flexibility comes with a price. So for numerical crunching, never do this. Never use lists. For the small things, yes, it's okay. How you remove elements. Think about this like a pile list. Every single time that you append, you put it on the top of the list. When you pop, you are taking from the top of the list, on the stack of values, except if you indicate a different number. So pop here is extracting from the top of the list, the stack of the last element, and is returning that, and is working. Slicing. This is very similar in some language, like MATLAB probably has that thing. This is something that probably if you are used to see, they don't have that kind of thing. As far as I remember. You can extract portions of lists. There is something like this. Let me see. This is one way of creating a list, but in Python 3 it's not actually a list, it's an iterator. So what I'm doing here is converting this iterator into a list. This is another difference between Python 2 and 3. This is like a promise. If you ask me for a new element, I will give you, but I don't have the whole list with me. This is a range, it's an iterator. It differs from how Python 2 used to work with this thing. I am taking this list and creating a list from that iterator. So it's exhausting the list, the iterator, and give me all the elements that you know produce the list. So I'm printing the list here. This is the first thing. This is the list. I am taking the third up to third and fourth element. So the way you should think about those things is how many elements are you taking? Is subtracting this from this. 4 minus 2 is 2, so I am taking 2 elements here. Which 2 elements is this? Is this one, because this one is the element number 0, 1, and 2. So it's taking this one and this one. So it's taking from the element number 2, actually the third element, because the counting is starting from 0 up to the 4. So 2 elements. It's confusing, I know, but they start from 0. They start from 0. And here is taking the elements beyond the third element, all of them. This is taking all the elements up to the second one. So it's producing 2 elements here. And this is a nice way of getting the last element for a list where you don't know exactly how many elements you have. So this is how you get the last element. And you can change directly elements in there. Okay. Lists. You will have time to play with lists during the exercise. So the tricks are on here. Loops. This is the only place where I'm doing this kind of silly thing. This is how you make loops. This is the only way to make this super easy. Different from other languages like C, where you have to put an initial value, a finite value, and increment. This looks very similar to what the kind of things that we did last week with shallow scripting. You have a list and you are iterating over a list. So in Python works like that. The for is for iterating over list. Actually, so iterables. So for things that can produce next and next and next and next element and next element. So more than just list. You can create this enumerate, and you can associate values for each element that for something that originally was a list. We will not enter too much. This one is interesting, list comprehension. It's often used in scientific computing, and it's something that we use in the quicksort. So, you know, if you want to understand the quicksort function, this is something that you need to know. This is one way. You create a list like this. And you can use this kind of looping to populate the list with values. You can replace all that, all this, from here to here, all those 3 lines, with this equivalent operation. It's called a list comprehension. So let's work a little bit with this. And I can actually get exactly the same. And even short. Explore this. You can actually do something like this. You can double iterate. This is a very compact way. But as soon as you start understanding this, how those list comprehension work, you can do a lot of complex things. That's one of the reasons why this quicksort is so short. It's so compact, and it's still very expressive in the language. So those are called list comprehension. If you are not obliged to follow this, but try to understand what's happening here, and as soon as you do that, you are replacing this kind of things with just one line, and the code looks still very clear. Here, okay, this is another thing that I forgot. You can also make conditionals inside there. So here is replacing an even more complex thing. You're replacing a loop that also has a conditional inside that loop with just one line. So you have a list of numbers. It can be an explicit list, or it can be an iterator, as I use here for the range. And I am doing the square of those numbers only if the number is divisible by 2. This is an even number. So I'm getting all those 3. So I'm adding a conditional here. This conditional is inside this loop. If you want to write this in the hard way, it will be a 4, and inside that 4, it will be. By the way, this is important. I forgot to mention. It's so natural to me that I forgot to mention this again. Different from C or other languages where you have open brackets, closing brackets. Everything in Python is just keeping good indentation. The indentation is important. That makes the code clean, much cleaner than you can produce with C. You can write an entire C program in just one line with semicolon, open bracket, closing bracket. Nobody reads that. But in Python, somehow the structure of the language forces you to put some nice format into it. The amount of space is up to you. The recommended from document, it's called a PA, is 40 spaces. That's a recommendation. Nothing in the language forces you to be just 4 spaces. So exactly the same will work if you just put 2 spaces. Exactly the same. From the point of view of the language, it's okay. But you have to preserve that. If you are putting this crazy amount of space, it's okay. That's a good compromise is 4 spaces. And I forgot to mention that. So let's compare. Dictionaries. Dictionaries is another way of storing data. In this case, we have a key and a value, and a key and a value. Let me create something not so silly. So and after, you can add more key and value elements to this dictionary. So this dictionary is also something that is flexible. You can grow, you can remove, you can do things with this. So later, you can increase. This is a nice way of keeping the data and the meaning of the data close together. Again, if you are doing this for large numerical data, don't do it. Don't do it. It's not efficient. NumPy is much better for that. We will see that. But for a small amount of data, for collecting some elements, this is okay. This is acceptable. And I use it. I use it for storing even quite amount of data. This is how you can print specific elements of that, or this from that. Oh, and okay.
I'm sorry.
Yes.
I missed how it printed true under the cube. Why did it print true?
Where?
Under the cube card.
Up,
A little bit
up
up.
another one.
Up one more. Up.
You got over the 50 there.
Oh,
53.
53. Oh, here.
Yeah, why print
Oh, let's see. Oh, okay, let's go back here. So this is a dictionary who has 2 keys. Actually, you want to see those keys? Let's divide. Let's understand that. D. So D looks like this. If you want to see the keys, are those. Those are the keys. So just this word and this word. You want to see the values, are those 2 ones. Oh well, 3 because here they add another one. Oh yeah, here I add later another one. So it's. Let's see if I can. Yeah. So this is the keeper. This is a key. This is a value. This is a key. This is a value. Here I'm printing just the values or the keys. Here I'm printing what is the value associated to cat. So it will be pretty cute. This is answering this conditional or this question. If cat is in the list of keys for this dictionary D. And the answer is true.
Oh.
So we will have, again, opportunity to play with this during the exercise. I have some dictionaries to work with. Okay. And you cannot do this. Well, we'll make an throw an error if the key is not in the list of keys associated for that dictionary. This is another way. This is very particular for dictionaries, where you can return a value or a default value if the value is missing. For example, imagine that you have some statistics from the countries. And if you want to extract some value for something. But if the value is missing, you want to put 0. So this is a way of returning. If the key in that dictionary exists, give me the value associated for that. If it doesn't exist, return me this. I don't know how clear this is. Let me see. Let's do it with another example. Let me see. Imagine that we have some value. Say imagine. So I have the dictionary with a couple of keys here, and I would like to get actually better to return. I don't have a key, so value, for example, for this, imagine that this GDP, gross domestic product of countries, but I have a country where I have no data for that. And for me, for some reason, it's useful to just put 0 on that, but I don't know why. So I can use this to return zeros in case that this key is missing in that dictionary. Or return a different value. You can, for example, normalize with the average. Instead of not getting anything, I can use that, but this value will receive the average of all the countries, or the average of some similar countries under some selection. Okay, so this is useful in some cases. Okay, yes. This is how you can iterate over a dictionary with a for. In the case of a dictionary, it's different from the list. In the list, you are iterating on every single value. So it will return me the value. But here is returning just the keys. The iterator in a for loop is just returning this. The first time that it picks this, it returns this. The second time, it returns this. Third time. So, do not trust the order of the dictionaries, because those are things that have changed in Python. There are ways with some other things, with some other collections, different in standard library. I will show you that a little bit this afternoon, where you can preserve ordering on the dictionaries. So you should not assume that I'm creating this way and I will return the same way. No. For some versions you can trust that, but this is not universal. So again, the iterator here is working on this, returning this, and this. And what I'm doing this is to select, associating this variable lex to this content here. So the value for this. This is how you iterate over dictionaries. Again, the only way to see this clean is with those silly examples. I have something better. This is another way. This have changed between Python 2 and 3. It's another small thing that have changed. Forget about Python 2. So this is the way you should learn it with items. It's basically returning the couple, the key and the value for that. So I am getting this, and I'm printing this first thing here, the second thing here, the key and the value, the key and the value, the key and the value. So you are iterating over both things, and you are getting both things during the iteration. Sets. Oh, yeah, I forgot this one. There are also list comprehensions for dictionaries. I never use it as often as I do for list, but this is something that you can use. Dictionary comprehension. Sets. They are like this. Like dictionaries, but without values. Just this. I just put it there for completion, but basically never use those.
Here, let's take a break.
Let me see. Yeah. Let's see if I can. Or, let me see. Okay. Let me finish here with the tuples. 5 minutes. We finish with the functions and go back to the exercise.
Go up to
Yes.
generic comprehension. Yeah. So,
Which one? Here?
No.
Which number?
Tell you what. Down.
A little bit lower.
Lower.
Low.
That one.
Yes. Why?
Yeah.
Is X double dot necessary inside this? What that means?
With the meaning of this, how you understand this?
No, I understand this, but what's this X double dot? Dot at the beginning, yeah.
Oh, yes. It's associating this as the key and this as the value. So this one becomes the key.
Okay.
By the way, in dictionaries, the key doesn't need to be characters or strings.
So we have the same variable for
The same, the key and the key is an integer and the value is an integer. In this, well, you can do something like this if you want to do it. In this case, I am converting this into a string, and it will, and I can do something like this 3 times. You can play with this a little bit. Those are things that you can do with the strings. You can multiply by a number means concatenate this 3 times. So I'm creating a key that is actually the string version of the number concatenated 3 times. So I'm getting something that is yes.
So you can convert a list into a dictionary by just adding that variable and then the double dot and then the
So
value.
you have a list and you can create a dictionary comprehension and convert it into a list with that. If you know, let's say, if you want to associate. Or you have something like this.
So when you put the double dot, means the first part is the key, the second
The
part.
first part is the key, the second part will be the value for that key. Okay? Yes. So let's finish with the sets. No, with the tuples. The tuples, it's works like a list, but you cannot add values to it. You cannot remove values to it from that thing. I use it for things that never change the size. For example, the positions of something in space. So I know that if I am working in three-dimensional normal space, and I'm not planning to go into folding the space, creating 10-dimensional space for anything, tuples is what I need for declaring the positions of vectors in space. They work faster than lists, but they have that limitation. You cannot append values. You cannot remove values from those lists. So that's why they are called immutable. It is the only purpose for them for those tuples, and they are used often, but not for crunching them. Let's wait 5 minutes. I will mention briefly about the functions and classes a little bit, and move into this difference for those who are coming from Python 2, and mention a little bit the difference, and move to the exercises. The exercises are right here. Here. So if you go here, we will see some exercises. Oh, we'll play with them. Okay, 5 minutes, and we will close this sentence. Shape. Oh.
But my students are online. They have a favorite. The other has a lot of ones for a reason we couldn't pick up the spot they just picked up right. So we're still right. So the other ones are not already. I can only like to 45 or something. Okay, this one. Maybe somewhere in here.
Anybody need to work? See
Pittsburgh, there was a lady that said Cool Peaks L830. It's one of those. Hey.
Yeah.
Good, how are you? Nice to see you here.
Couldn't make it last year. How's your research going?
Well, I just restarted my last 3 years all from scratch, so great.
Thanks for all your last 3 years.
Hey, it's my last 3 years. Basically, this other stuff I used to make work, but not really excited.
What happened? Just glaring errors, setups.
Yeah, all the tutorial said about using fluid adder. I really look forward to it. Just to use it as a great commercial company. However, when you run the simulation starts up the amount of complex cell, it's 5 numbers. Because of that kind of pressure, like all 3 dimensions that you can go whatever you want. And so what ends up with some, what happens to other people is that the z-axis kind of stays the same, but the x and y-axis will have one side that will switch, so we'll end up with a square, we'll end up with something around.
Yeah.
And obviously a lot of your conditions you will have to protect those themselves. But nowhere in the entire thing is that So you have to use the pressure one. But you have to use the specific. You have to use the specific one. It's no, I'm not going to be too long because it's going too far from your part of it. So I have to, what I did is that I structure a multi-file that has 38 structured for this has been like a kind of like a range kind of thing. So I'm all
Just that's the most under.
and then you have all the other things that anything that needs to clean up. Yeah, I just have to tell all my partners.
Who you have programmed with Python before? You? Little bit? Okay. You? Little bit. You? Have you been working with Python before? It's your first time? Or?
First time, but we do a lot of
MATLAB. So it's kind of similar a little bit?
Yeah, a lot of, so far.
The syntax, for example.
Syntax is a little different, but.
Okay. But programming is something that
I know a little bit.
is this, too fast, too slow? What you feel? Too fast? Well, you will know when you start doing the exercises if it's too fast or bad.
The best way is to truly
How much is too much?
but you put in a ticket. If it's something system wide, I can answer it. But if it's something science wise, oh my gosh.
Yeah, I'm talking about.
But
So
that's
my idea usually is like, oh, everything is going great. I can try to evaluate these things. And then this time. I don't have a life, which I don't, so it works.
Let's try to have that much.
Okay, yeah, well, 15 minutes and 10 minutes and I'm go to the exercise.
Do something else.
No? Okay, so there is just a tiny little part that I will mention. Quickly. Is this. Functions. Functions work like this. All that you have to do is to put this word, the name of the function, and in parentheses, you can put arguments. I put a name for the arguments that you will. Those things that you put here have existence only inside this function. And here you operate. When you need to return something out at the end of the function, you put return. And that's something. So in this case, this function, when applies for -1, it will tell you negative. When applies to 0, it will return 0. When it tells 1, it returns. This is how you define functions in Python. Python is a language for what is called a multi-paradigm language. So you can work with just with functions and will be what is called a structured language. Few functions, variables, and but it can be also be programmed in a object-oriented programming. In that, in object-oriented programming, there are a few concepts, but the two main concepts are around that is that you cluster together functions that at that moment would be called methods and variables, and those variables are tightly associated to those methods by becoming part of the same thing. So this is how you define a class. This is a very minimal class in Python. I will not enter in details in object programming. It will be far beyond what this class is for. What you won't have to know is that to create a class, you put this word and this. Eventually, you can put more things here to declare the parents of that class. There are another concept in object-oriented programming that is inheritance. So you can create a class that is a child of another class, that is a child of another class, so you can put that kind of thing. Objects are initialized, and they're initialized with this function. So when you create something like this, an object called G from the class this is receiving this argument, and the first thing that it executes is this init function method to create an object of that class. Don't worry, this is too much. I just need to mention this a little bit just to complete the whole picture. But if you need more time, I'm probably not doing any exercise related to this kind of things. It's just to complete the picture. And I can execute functions. And here is where it comes, this dot something notation, the dot notation. I can apply a function or method, this, to the object that I have on my left. So when I executed this, for this object, I am calling this function. And I can add more variables here, more arguments, and those arguments can receive default values. That way I don't have all the time to put the arguments, the entire arguments. Some of them can be taken by default. This looks like a function, is a function, but it's inside of a class, so it's called. So let me show you a little bit for those of you who were exposed to Python 2 at some point, and quickly the difference and why you should not, when you see code, old code, realize, oh, this is Python, so I should start doing some changes or not using it at all. Three main differences, there are more, between Python 2 something and 3. First is the print. This is how you print things in Python 2. Python 3, you always have to use the parentheses. There's a big difference. So you cannot execute this. That's why I disabled this. I put it like a row. You cannot execute. If you try to execute this, you start getting syntax, invalid syntax for all those things. And this is another important difference between Python 2 and 3. When you divide two integer numbers in Python 2, you get an integer. When you divide two integers and they don't have an integer division, it returns a floating point number. It returns a real number. To get a real number. So this is important, and this is important and subtle. Means that you don't get any error by converting this into a code, except for the prints, but you will get a totally different answer. So this will return just 1. Instead of 1.5, you get 1. Here we will get 1. Here you get 1 and 1. In Python 2. Because 3 divided by 2 is 1. They don't return the real number. They don't return the decimal, the number with the decimal. So this is another thing. Except for the print, if I put parentheses here, everything works, but produces a different result. And another important difference, at least for me in scientific computing, is using this X range. It's no longer used in Python 3. It's something that people use to use with Python 2. And the difference is that this one produces an iterable. It produces this tiny little machine, invisible machine, that produces new values for the list without actually having to get a whole list. So I create a range, for example, an X range of 10. It will not create a list of 10 values. It's just a promise. When you ask me for the next one, I give you 0. When you ask me for the next one, I give 1. I produce 2, 3, 4, 5, 6, 8, 9. Without having to store in memory the whole list. So people used to put this in code or when they want to use that. I have here one example of using the range for a multiple loop here and the X range. And I execute it on a Python 2 so that I cannot reproduce this on the notebook. But you can see that the X range takes almost half of the time compared with the range. In Python 3, range behaves like X range in Python 2. So you will get this kind of timing. But you need to realize that it's different from it used to be. In Python 2, range was actually producing the whole list. The whole list, the explicit list. If you ask for 10 values, the 10 values. There is also difference. You can make also the difference with the memory, how big the variable is. So maybe I can do this really quickly here and show you that. Probably will show that for tomorrow or this afternoon. But anyway, I can do this. Okay. Import this. I need this.
If you write a code in Python 3, you can run on Python 2.
If you what?
Write a code in Python 3?
No.
No?
No. It's entirely different. You cannot go back. You cannot go forward. There are libraries that help you to manage that. There is 2 to 3. There is Futures. That's something that I used to use. Futures to help me to having the same code working on Python 2, on Python 3, and for example, for the print, you write the print with the parentheses, but in the middle, this function will help me translate that into works like a function and instead of the statement. And for the division, it will help me to work that. And so you put like from future import division, and so you get that working nicely. But no, consider those different, entirely different, incompatible languages. And you should understand this just to forget about that. Yeah. So yes, so if I execute this range, just mentioned, if I execute this, I get this range from 0 to 100. This is a very tiny object, different from getting an explicit list when I'm actually creating the 100 elements of this list. Working with those iterables is much faster. But I will show you. Now I will show you this afternoon with when the iter tools. Those are iterable. You will get the picture. So okay, and there are more differences. I found this blog interesting for knowing those things. Just to close, there are a couple of things that I can show you that outside, because I cannot produce that the same effect on the notebook, is how you write scripts and how you write more complex code. So you saw interactive computing, you shift enter, and you execute things, you change here, you go up, re-execute, go back, down, down. And Python scripting works like this. You write the code that starts with this magic thing, very top, that indicates that this piece of text is meant to be interpreted by a Python 3 interpreter. So that's one thing. And you put the code that you want to execute, and it will execute the code linearly if you write this way. If you can improve this a little bit, start creating functions on that. And again, the code executes. What matters is to put this magic in front of the file to create a script and change permissions to that file to become an executable script in Unix. Otherwise, you cannot execute this. So with this command line, and this is something that you execute in the terminal, you can convert this into a file. Maybe I can do it. Maybe I can do it. Copy this, and come in here. Let me see. And this should have EI, probably B. Let's call it test. So I imagine that I wrote my code. EI. So I cannot execute it. I cannot execute this. This code is not executable, even if it's in a script. So I have two options. I put Python in front of it. Enough. So if I executed this, permission denied. If I can execute this, put in a Python in front of that. Actually, Python 3 in front of that, or making the code executable and execute the code. This is the trick for moving, and actually what you can do when you are working with the IPython console and this log start, it will store all those commands one after another. And later, what I typically do is that I open that file and I start cleaning mistakes and that this is wrong, delete all those things, and I end up with 20 nice lines that do exactly what I plan to do. And this is my first script.
So if you don't put the magic stuff.
If you don't put the magic, this works,
Right.
but this doesn't.
Yeah,
Because it will, let me see if I can mimic that, but imagine that I put something like, probably can do this, something like this. Comment, but a different way. So this works, and this doesn't have an interpreter. Doesn't know what to do with that piece of line. So we're not interpreting from there. That's one thing. Another thing is you can start growing this a little bit more, and you can even have these classes on scripts. So same thing here, and adding something else here, the module that is part of this standard library to collect arguments from the command line. This is probably beyond what I will present today, but this is one very small example how you can create a script that actually takes arguments from the command line, so you can put things in front of that and using classes. So it's small, but adds a lot of, I am adding a lot of complexity that I'm not mentioned today on this. When you start working in large developments, what you do is to create a structure. And this is how you structure the code for multiple Python files in modules, submodules, and things like that. So you create folders, and on every single folder you create this file. This file is perfectly fine if it's empty, but it has to be there. And you can create more folders and more those things and more Python code. And if you like to do something a little bit nice with, for example, this one, to import these utils and get the functionality inside this periodic and thermal, you just create this init with this content. So you can start getting modules and modules, and you can import that later. You can import chemists, and you will get that functionality in a structured. For example, here imagine this. I'm doing some MD calculations, so I have one code that contains the properties of atoms. Well, do that. Some thermodynamic properties that I would like to associate in that. Functions, and I would like to export this, and this is for I/O, for input output. I'm exporting in this format or in this PDB format, and I have some other function classes or methods and things for moving atoms or for relaxing molecules or things like that. I start structuring the whole thing, and this is how I create. We will not mention. So I will not do anything with this, but just to complete the picture, you can also create web applications. And it's relatively simple to do. Those are very simple libraries for doing that. Basically, what you do is to create an environment where from the browser, you can start adding different elements to the URL, such as that you can get different outcomes. So you can get a table or get a plot on the web created on the fly from a web application. It's really nice for some things. And it's not hard. Don't think that it's super hard and you need to know CSS or HTML, not that much. You can do nice things with very simple elements, and those are two of those tools that are very good for that. And you see the notebooks. So now you have all these 40 minutes to play with these exercises. This is easier, so that's why I play with just your name. So use your name. It will be create a new notebook if you like, something like this to do your test. Examine what you are doing, trying to do that. If you got stuck with something, the date is here. Scroll up. It's up to you get what you need. And this one forces you to use lists and eventually playing with conversions between numbers and strings and things like that. So it's made to play with that a little bit. And this one is playing with dictionaries and a little bit of math. So the idea with this one is that, you know, there are 5 platonic solids. Here I am collecting a table of different properties of them. So the number of vertices, edges, faces, and this symbol. And the vertex configuration. So notice that this is not a number. So you need to figure out how you will store this, but this is not a number. So basically it's telling you that on each vertex of a tetrahedron, there is a triangle. Each vertex has 3 triangles attached to that. So this is what it means. And this symbol is used in mathematics to declare the number of edges for each face and number of faces for each vertex. So there is a nice property from Gauss. So this is Gauss did so many things that there are so many Gauss equations. So this is one of those Gauss equations. that basically says that if you play with those numbers this way, you get this identity. So use the dictionary, build the dictionary, and use the dictionary and the elements of the dictionary to confirm that this is true for all those polyhedrons. So it's simple, but at least plays a little bit with numbers. And again, figure it out how you will store this and play with it. So you have like 40 minutes for playing with this. And if you got stuck with something, tell me, I will be around. If people online, we will see, you can try to copy and paste the code if you got stuck with something. Otherwise, you can tell me your username. If you got stuck with a big portion of code and you got, I can enter with your username and see you on the fly the notebook and check if something is not right. So play with this, and here is where you learn. There is something that you will need this for, if you like. There are several ways to do this, but you can do it for a for loop, for something that you will see on the first exercise. But there is a fancy way of reverting the order of the list. And for most purposes, a list and a string work the same way. And it's this. It probably is there, but I'm not super sure that I put it. So it's basically iterating the list backwards.
There is a method called reverse.
There is a method reverse. So you can do this. There are several methods. Or you can create, or you can make a for loop and do it one by one, or create a new list or something like that. There are several ways of doing this. Let me see. Yes. The difference between this way and this way is that this one produces a new list, but the list is the same. See, I execute this, but A continues to be the same. Reverse is doing that in place. So you destroy the original one and get a reverse. Yeah, raise your hand, call me if you got stuck.
So would you like us to do it in the?
You can create a new notebook and in Jupyter and start playing. So.
Yeah. Sprinting.
you should put something like dot capitalize here. Also, you will capitalize just it's like so that you get this.
So like
First plus space. So just nothing like that. Capitalize. Autocorrect is good for autocorrect is good. So after the parentheses plus. Wait, okay, try to check dot capitalize and see what happens. Okay. And now
I need to enter.
exactly.
So our research is pretty clear with those.
And so Tom is like first time I think he has.
So now this is how you can eventually define
Nine times out of 10.
put this tag.
So like just copy.
Okay, so yeah, copy that. Put it there. The parentheses you keep shipping with that. So now you can create,
I did that. It's correct, but it's always not the string.
and
String is not the list.
string is not a string is not a list. They behave like a list in the sense that you can keep going on and on. This is
They're not the list.
it needs join. So it's an empty space or an empty string and I am concatenating.
But I think it's so I just write.
And this is one way of doing it.
So this would be yes.
Yes. What you do it?
The same result. So I need to do that.
Yes. Or you can start with something
Like that.
like and you here that's you start collecting this thing. No, actually no. A penny for this.
Red plus.
Or
Red plus.
oh, yeah.
yes, because the way you're doing this is fixed, right? And in that case, yes, in that case, you will not be doing this comprehension. So this is the 4. And so here you have to do it the different way. So you can put the 4 and instead of 4 instead of it, because otherwise it's not. Yes. So the first one is
I looked up, I was trying to find a way to do what we're talking about where I use pretty parts. We haven't found that yet.
Yeah.
I didn't find how to launch EC2. On it. EC2 is
Oh, it's way easier that way. Yeah, I need to check through this.
I found
About that.
So we have now, we can use that for the future. This is the
Yeah, I want to show you how this here. So this is this is what
this is where we are.
is you interact with the house and have launched to a certain age. So you click that, that'll make the launch to the moon. So you click that.
And this is what we use.
Launch.
for the
It's free. One of it is free. This software is you get access to it. So you just can type this right here. So I need to
We need to work
make
together.
it
But this is where we are. This is the nice.
yeah, and the cool things off the table is
For our student. For our student.
I have tried it. That works really well.
But this is our student. Or
It's our studio. Yeah, it's like
we
it's
got
just-
Jupiter coming down.
yeah, it's totally just like
what's the next one?
so this is for our servers. These layers.
But on our lots of you here.
You should have done it if you're there, yeah. You can see all this, you know, moving plots.
The
There.
dots you
It'll be in our studio server. They'll show.
top of the thing.
You also
They show
this pane or
straight or we sort it
It'll show, well,
We sort it out.
it won't show either of these,
Or we show it here.
but you'll create like a markdown file and it'll show it. Then I'm guessing it'll save it here, and then you can open it here and show that. I assume. Plus that, yeah. Yeah, there's one different ways.
Very
Here, I have a question. Okay, so why am I've not used this whole this interpretation.
But if you are doing this from the bracket.
Okay.
The bracket.
Otherwise it doesn't know what I'm doing. Alright. So I just have brackets and it should.
Oh,
And I guess there's a great set
Now
for
you
you
have
this.
concatenate.
Yeah.
And the trick is concatenate that.
Are you doing the That's what the name is. I think it's 30, yeah.
If you want to do it, it's not a far drive.
Okay. Cool. Okay. Sweet.
It's also for this one.
Yeah.
Probably not in the UK.
Yeah. Usually the last streets. Thank you.
Okay.
I found
But
found the difference like ABC range Python 2 words.
you have also
I used to work with Python 5.
But you're
So I will have to pay.
So So what this does is it'll let you basically what that does is it replaces the employee for all of those non-federals to do.
So, did you want to go to this? This next Thursday.
That was one thing I was.
Just let me know.
Yeah,
But
maybe,
clearly it wasn't worth
Oh,
everything is the same.
same thing.
Otherwise. And people,
I don't know.
who is behind that?
You know, yes.
Just that or it's something person.
Just, yeah, I don't even think it's not just for hiring, it's just.
Yes, it's what I like.
I think we got invited because we buy stuff.
It would, yeah, I was checking that. It's a doctor.
Instead of using the normal thing I had with
Oh, here's
very big there's marks.
At least I suppose the question. So let me concern. One thing is that it could be some of one is that for example, or they accept me, but they pay. So which is okay.
Yeah, the other one. I don't know if that's the case. That's a lot.
How long have you lived here for? How long, how many years do you live here for?
Oh, and then you have that at home.
I don't know much about that works, but how is that not enough time for that kind of stuff not to be a problem anymore?
No, this was for 3 years. The extension for 3 years. Since the time was granted, and it was granted in September. Their companies is from September.
You probably do. So what happens when that?
No.
You get another extension or you get a
That's
different?
what
because well, you need to print that print exit. It's not going to do anything.
So you just said that's my area.
Yeah, just because we're like this whole interactive show.
Still giving you space.
Yeah, that's because you put a space in your AI view.
I did say I did look for lots of things you can't use it.
With a special circumstance,
You, that might
more
be,
lawyers, more money, more time.
that might be, we have three years.
Since we start, yes, more than we. Since we start republishing about any data set and Charleston, something like that.
Oh, yeah, we had it.
If you come from, she's not.
Yeah, actually.
Where we going? It's something like that one.
They try to take trips.
It's got personal trumps.
Yeah. I don't know. So how do you use so much for the applications?
We had a job, he's already hired, so we actually had a job on it. It's so for us, yeah, we had people. It's like fine. That's fine.
So you have to collect that. That's what you call request for it.
So they do actually, if people applied, you were able to say that they don't have qualifications, so it doesn't matter. Say that at least they don't force you to get it, so she's gonna qualify.
Which is okay. It's like, that makes sense.
We should also be tracking this one.
That's part of it.
I was assuming, like, you would show that, or it says it's making money for the country, they're gonna money back to the economy. Great.
That's why they this is their thing. That's so she can come how many times to qualifications? So how many times they translate. Right, that's use. Yeah. Like that. All the this is possible. But also complex.
Yes, just getting $100,000 for.
Yeah, just wait.
I remember seeing the same. I've never seen a picture of he was in a business suit. He was homeless. He had a business suit on, holding up the resume, like a sign. Fair house. And this guy had a master's degree, like 3 different programming languages, had all this experience making stuff. And he was homeless because he can't afford to live it. He was out of a job for a couple months. That's all up. That's someone who's extremely smart. Qualified to work in a lot of places. I used to think I wanted to cut a big city. Then I started actually looking at it and seeing what it costs. Now I interview people. I had it was like a that asked me that. No, because it was during time. Pause. But I still wanted to apply. Right, waiting for people.
Which
It's not even like yeah, the way they special. So I had like I'm sitting at home, I have to dress up.
Well, learning a thing.
So, good question. Here's of course, I like so,
Letter by letter. The letter is I work. I like the of you. Otherwise, I can get it.
It's just because I wrote this one line of thing. That's all over.
Something like this.
selfish reasons.
Another way is you want
I think, yeah, I did. Oh, yeah. Sitting still legal. You have 10. You have access.
For an empty
So X is kind of like what you're putting in your list.
I mean, I know the iteration.
So now you can move it on. Except for the
So
you want to do the
I was not that part. I don't understand that part.
here's the X.
I love the X part.
No.
Well, before X, it's the bunch of variables. But this X, you're adding a split. First, you bring
next. You
Oh,
replace
by
all
leaving
the
through, so you
extras.
see the X is
Replace.
if it's not the
Replace A.
Lots.
there's all
Check now you know.
Okay.
This is another way. So this is but it works as fine.
This is the better sort of way. You can separate them.
Are you sparing?
He had a
So the idea is that the idea was to start when you see one like that, you get another pulse. This is lower speed. When you replace this screen has another operation that you have.
You actually operate what's X-ray.
Lawrence is not given the same.
Always new checks.
I know. We have different functions. You name consequence.
If you want to be, if you say person section, person this additional.
Let me show you the small thing. This is again. This is in IPython in the notebook, and a small trick that you can apply
There is actually things
with this. For example, you execute this, and in IPython you can use this to replace the latest. Or you can use directly this like it's written there. And reuse those things. This is the Jupyter notebook that allow you to do that.
ideally nice. It's very powerful. No, but someone how it's you're one that you did like
Out.
Yeah.
And you can actually do that. When you say my
I was wondering, for some people,
we run there,
and there is something here. So like that.
well, it's time waiting. There's we go box by box, running their all. So imagine that you have this, and you just want to see what I have to do. Using this watch, how that affects the whole. We do the change. We run it up and see how the figure changes. I would like, for example, you're doing some, you have some. And you have some individuals working the coverage. And you have one parameter that is how good is the coverage. You want to change that a little bit to see more elements and how that would affect all the analysis. So you are happy with just 80% coverage, and you go to change it to 60% coverage. More elements. Yeah, all laws will change. Rerun the whole output and capture the difference.
We didn't also, we also had
We'll do all that.
Oh, yeah, no.
I know you stopped. Yeah, my plans. Anything else?
This is what we will see. This afternoon we will see how capture data from CFP. It's not Excel.
Yeah.
Capture that data. Change the patterns. Some of the examples that I can give are something on that data. That brings you can find it here. Yeah, it's almost even the download the data directly. And there are slides, for example, and there's sort of had all the
Left.
Yeah, okay. I'm gonna go around. Oh, no, wait.
So you far fewer numbers than I have.
Okay, so like, it feels like it was even the other way around.
Yes.
That's annoying. Well, I could actually.
What part of it? I mean, try it. Go in, try it. I would be surprised. Yeah, it is because this reads as a sage. There's also items.
plus it says for whatever reason. Was correct. Yes.
So if you guys want to go to lunch, we'll still be in here. It's gonna work. We'll meet back up around 1 o'clock. There is a cafe downstairs. Doesn't have much. We're gonna go walk around. Guys, if you decide to leave and the parking pass to come back, just come see me in the back.
Oh, sure.
Yeah, so it's going to be, probably, in
So
yeah, I don't know about it.
What I think is that the previous one actually leaves out all these ones.
Or,
The previous one leaves out all. Care about it, I'll say that much what
So if you're not ready to do some of this. So
yes.
you're still working.
Now you're lost.
They have it's more like a sense of playing or exercise demonstrating ideas.
It's
When they have access.
as long as it's related. As long as they don't care. I don't.
Which area is that? You work for
I use the ones Yep. If you actually, I don't know.
So you collaborate with all of them.
Get all the Saturdays. You still have to follow those.
You work mainly with SaaS.
Well, what are you saying? What were you saying 3 weeks ago?
The other thing we'd ask, like,
Yeah,
yeah,
You have the immediate pressure.
What were you saying that we felt?
oh, they get, oh, well, you don't actually need the next one thing, I think, because previous ones right now is already. Anybody else wants to but you have the same first class here. The advisor chair.
Not necessarily. That one was
Let's say,
taking.
I imagine that they throw you.
Oh, yeah.
For you.
One to one. Here's one is
But they got
taking
even
about
school the three hours.
Yeah.
Doesn't work. We do the same frontwards and backwards, if that's the half of the same person was here. Oh, you did. Right.
Yes.
Yeah, it's like a, so access is your own. Or it's like race car. I don't know, I've asked them, you know, very good. Man, listen, plan, now, it's great, but I just know sometimes. Are you waiting for what?
Trying, yeah.
Yeah, just, depending on what it is.
Which kind of
Still working.
this population?
Mas só pra cá, eles practice, like when he's practice. I
didn't know how to do it. That's good. Did she transpose some meat and a group or so?
No, she's staring at me because she said that she had to do something that she practiced. Sounds like her mother.
Okay, if you don't have time, you just ask for the last one for the machine. Because we have two machines, other one half terabyte, so 500 gigabytes of memory. That should be enough. So instead of tweaking, you don't have time to tweak, you don't have to try to review the memory footprint. Just touching the last
Well,
see the errors is memory.
it's not the best way because I kind of cheated like a deal because I did like a dump that we have for whether he's in the phone number that we have one or two, sorry, 24 days.
What
She goes
so,
and you don't have any
because this is the thing. I created one environment with all the categories.
just do.
I create with this username. I create from the environment. So all of this is students. And
So enter on string of X.
activate that environment, and it was last. It was all those for the node string was character. So that all the tiny little items to and then so Brody was choose this code. This is okay. Go to the cluster. So I can show you. Open up the review. Okay. So open up. Which is what Brody will do.
I believe it must.
Okay. So you put nice dates. You thought with biology. This comes from biology.
This goes to biology.
Because he is the guy and by for my
Yeah.
So over here. But Brody.
Maybe we're gonna
Right.
just not stressed.
Start low out. I know.
I don't think that was a little low.
Start low. Okay.
That's very easy.
Well, there's,
Use your name stick.
Big rough.
I did, I have to do that every time I
Yes.
table.
Good thinking.
Yes.
I'll give you a sign.
Well, I know you can do that.
You agree?
With either side.
Or two options here.
Yeah.
Ready, what do you need? Use
Look at me here.
You're fine.
your- yeah.
So I recommend doing that.
How's it going?
Gotta go through that, right?
Getting there.
Huh?
Getting there.
But that's the fun of this talk episode.
All right.
Nice, okay, got it, we're done.
Good second being awake.
Trying to finish up.
Good second being awake.
Number.
So we both have to be a week early. We can do it if it's late at night.
What did you advise?
What's that?
Is that
You
good?
advise?
Yeah.
I have. Dr. Flow. It's the me and Dr. Conlon. He's, they can't meet a partner. They need someone. Find a partner. Dr.
He's probably good. Well, we'll get covered.
It's not the.
And you missed that.
I'm just.
You cannot. It's a cannot.
Some actually. Cellulose.
Yeah, it's a kind of.
But the cellulose, like one stream together, so like the cellulose whole itself is like 130 angstroms long and that's 60 some wide. So I gotta count what's spinning too. So the box is like I mean, I'm doing a small runs, like 600,000 atoms, like small time runs, that really long ones. So, the long ones are hoping to get like 6 seconds. I have like different concentrations.
600 seconds.
So 600 nanoseconds.
600.
Like I have the one running.
How many seconds?
Yeah, it's about
performance. How many nanoseconds per day or per
roughly at 324 I get 15 nanoseconds. Or sorry, 100 nanoseconds. I guess that. You mean my portion of it? I guess I was just talking and said, what do I need to do to get like so like finish another paper? I have a lot of ideas that I've never really he said if someone sponsors me, like I can just get the community that's access.
Are you using?
Actually,
Which keyword?
I'm using Ishmael's setup that I have. It's like I have to do with it. So like the 1-4 interactions are different on different molecules, and with the dispersion, long range dispersions,
But you better come.
in ionic. It's like a tetrabutyl phosphonate hydroxide. So those are the normal amber 1-4 pairs, and cellulose is 001 1-4 or the 1-4 position 1 on both on the LJ terms. So like there's something with that. Like it don't like mixing that and then doing this other thing and just come all apart. When you know how it rates as restart files. So when you try to restart it, it just breaks. It says like because it's the dispersion, pre-flow the long range dispersion population. It's basically the same thing as long range. Only with LJ. So when you do that, it just loads up and says and too much, whatever. It says it goes all crazy. So I have to go BMD and then reconvert it to initialize data files. And then try to restart it from there. And sometimes it starts and sometimes it don't. And I don't, it's something in layers that's because it doesn't die, it doesn't align.
Because you have not died screws.
It's something in lamps that don't like because when you use under 24s, it works every time.
Okay. So you see some line. So you probably don't get stuck with some barrier or some boundary. More crossing the molecule with codes, breaking everything. And you are moving more codes, you are making more domains. Like that already get that very tiny. Nobody can match the nice.
Yeah. It's weird that you restart like 3 times, but it's failed twice and then start the third time. So you think it blow up every time. Yeah. Like I'd say 2/3 of the time it starts and then But it's weird because if I take out those certain features, works fine. Like if I take out that long range calculation, works fine. Or if I take out the non, don't like, there's something else in there, don't like on those multiple 1-4 coefficients, like for different molecules. Don't like that.
Sort of divide.
You do. It just don't like when you mix them. Like, you know what I mean? Like if you have all ambers, it likes it. But then if you mix them, this part with amber, this part with the glucose 1-4 coefficients. Wanky.
Good.
Thank you.
Okay, so you right. So if you see here what you're supposed to do, this is just how what this is what you are. Right. So you execute this, and you work inside. You have content. So now you should have a lot of those on that. You see, there are a lot of packages, especially tools, that say, all those packages that you have to back. Yeah, Python is just a child. It's exactly it's meant for what it's script. But you see that it's with this. Yeah. Well, you don't have to see. So you can connect this. You only use this and put that. Connect this line. You don't. Those are exactly what they execute on.
So like.
And after that, first step one. Okay, sorry. I fast use. Oh, so now we're memory here. So you know how big this is. Anyway, it doesn't matter. Show me the script that you made. Show me the script of this. Yeah. So instead of this, so switch it for this. First remove this. This time. Comment. Put that start. This is the first. Yeah, or whatever you want to have. you don't have that. So we need to use opportunities. This is what we use. We think it's complicated. It's that we need some knowledge. It's large one. This is a normal node. This is a normal node. It is. It is. This one, for example, I recommend this one. Also the list. You can use this one that has 500 megabytes. You can copy this couple, or this one. You are having problem with that computer. This Google. So what I will do, I will double connect this. See, yeah, double connected this that I'm not this home. This is the disk that you use in the machine. This is means that you are with one node, one machine, with one well, that's no reason for that. The world is fine. The problem is the issue. So that's one machine. No, there is no reason. One in the one this is a one big machine. At that. So we don't need it. I think that's that you don't need it. So this one is so that's scratch. I imagine you scratch. And this file. This file. Yes. I imagine the key that right. Yes. So if you are asking for 16 so correct. But ideally, you have you receive a machine with 16 cores, and you pass QC is able to use 16 cores simultaneously and speed up the whole process. Is the same thing as exactly why one machine 16 and what do you do is all of them process. I think it's a nice that is yeah. So classified and non-classified. Oh. we are using a much
lot of
this should work except for right. So we did S1 there. S1. Okay, so you have, let me see how big those are. Those are right. So, but not that much. It's 700 megabytes. Not that much. Okay, so we don't know, we don't have to know there. We don't have to know. Yeah. But we can discuss later. If you
Most of the tricks the other day, weird.
so can see what happens. We submit that. Yeah.
It just
We submit the job.
Yeah, I love it.
We get first file. We got to see the last week. It was being started. Okay. Thank you. Everything.
Talk to Becky.
Oh, yeah.
She said it's embarrassing.
What's it?
This year process, you can, or situation would be.
As far as reading the process.
So long as it's been in process. She say, she goes, I have to get that.
Okay, I'm sorry, something. I mean, it's good. But there was that's
Unfortunately, I have not seen and so people cannot take out a single user cannot take out resource yard, they're all under statute. Yeah, see, man, that seems to some people were starting to take every single resource. I don't know how they started to do that.
all work together. Idealmente, muito tempo
There's a question in the chat.
Oh, well, one solution was something like this. This is I mean, a lot of people solve this different ways. They are listening, right? Nate, people is listening to me?
Yeah.
Okay. To answer this question, the guy might think this is one way of doing one person here did it this way. Well, it actually this way. Name dot lower. It will be like this. And after you can start to replace hey, but nothing. It will be like this. Replace, and you can concatenate this. Replace E. And that way you can go. It's dirty, but that works if you want to do it that way. Another way is to make a loop on your name. So something like this, red and for names. Like this. Oh yeah. But yes, that case. Those are two ways of doing this. Yes. If you're, this is a concatenation of operators over this object, the name, and this is with the loop. Is that okay? That answer the question? will try to eat something.
But I was able to install that successfully.
All right, all right.
Your computer. Okay. But I already did all. Okay, this would not work on because it's my computer. No, it's because this line only works. Can I leave this one? Yeah. Oh. So you install Jupyter right here. So you have two options. This is the iPhone 3 that Jupyter console, the normal one. We have this console. No, you don't have to. You can install that. You can install that. Are you used to the people you using Firefox?
But after we're actually I'd like to
But it's people. Just go with the install. Search. That's good. So I never tried what you are trying to do right now. And what I do is, do you have Mac OS here? You have improve when you something like that, or if you want to explore that without asking much if you don't. Just installing an app on there. You have all the things. Yes. So, and regardless of that, forget about the YouTube. Now you have your, and now here you're connected. But so that's good. So here you can only mix it with 9. Or in this house.
but you can't do math all of it as long as it's not in line. So just
Yes,
it's fine.
it will be something that you just not like this. It's not good.
Let's get
There's
on.
more. There's more. Same comments. Yeah. Okay.
So you know how
I got all.
protein, so
You, if you have it right now. And if you want to use the word,
let's say you could do like whole foods.
you can also,
Yeah, so
like
like
natural, you can also get
just funny because it
not
still sounds like a grocery store, but
or
full numbers and natural numbers.
that's another thing.
I see where you're going. I see where you're going with this.
It's like, yeah, actually,
I'm not sure we can like show up Yeah, not sure if you can show up in terms of anyone knowing what was going on.
What are you working on? With agents, we just want to do is with agents.
Basically, words, graphs, so that's the.
So you map the problem just into a solving. It's optimizing the problem.
The drawing, now it's. As a.
Oh, do you see me?
So you need to know it.
So you need to you want to introduce one for structure.
So when you have that. So you have to follow.
You have the politics. There is, you have worked with networks. It's like this is the problem. This is what at least to get some configuration. It's
Give her one line.
so it's not for visualizing networks. You can use something like for graph B. So there are some other things for visualizing networks. But this is for working. There are properties or operations for random networks or getting a shortest path. For computers, let's say global properties of the networks. What is the average hash? So on and so on. All the so these sorts of things and for networks. Or that you have to do some application install. I use it for the kind of thing that I use it was not even it was just different crystals, different compounds, and I was relating those symmetries. So how the different crystals are close to another, close to every foundation board from a graph. So basically, we define graphs. So you can start adding nodes and edges. Very easy.
Yes.
Create those, or you can create paragraphs. So there are some predefined graphs where, for example, everything is connected. So everything. Those templates for some graph. People who study this.
I did some code.
This graph that exists on this graph. Later we can please. And do you got second here from these? Okay, we can see. Here's that. You got some. apparently, no error. It seems to be no error. Analysis complete for the. I don't know what's supposed to be the output, but it's scratch. Maybe this is the analysis as the output. That's what I imagine, but I'm not for this C file. I don't know if that for that code probably produces the HTML where you see the quality analysis. But that we need to figure out how to expand the same procedure for the code master file. For all of them. Good morning. In 1 minute, I fill this water. Okay. So go to the dashboard and open the second notebook there, and we will discuss about the Python standard one. Okay, but itself, Python is pretty much what I show you for the lists, dictionaries, with lists, dictionaries, tuples, and all those variables, complex numbers. You do most of the stuff, and how you define functions, and we touch a little bit the classes. That's the language. But a computer language is not good enough for today's purposes if we just rely on that. You have to build the whole thing. So many languages today include a standard library. So collections of packages that knows the recipes for doing certain things that people do often. Java has its own, all languages doesn't. For Fortran, for example, doesn't have that kind of things, but Python does. Python has a large collection of modules that you can take for granted. They are there. They probably work differently in Windows and Linux, and some of the functionality in Linux is not present in Windows, and vice versa. Or there are some small details about that, but in general, they are there, and you don't have to ask the user to install more packages. If you have Python installation, it should be there. You see the list is large, and you will not learn anything. You just pass this as a reference. All this blah 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 blah, and you learn it. No. So what I did was from this select those small, very small subset, or those that, from my experience, I have used the most,
They are the most numerical related operations, yes?
How is this view? So I can use the library and publish there, something like that?
No. Well, not directly. So this is something that is, let's say, curated by the people who develop Python. So this is part of the standard. This part of the standard library is the people who produce Python. There is a community of people. Some of people is devoted to the language itself. So those who move from 3.6 to 3.7 and they decide, okay, now this will not be like that. Now we decided the X range will not exist more and we will replace this by range. And they declare how any implementation of Python should work. There are several things that are separate. One is Python as a language. What the people do is to write a book. This is how Python should work. Other people do an implementation of the language. So this, okay, according with the book, I will create this implementation, and this one that you download here, what is called this CPython. It's an implementation of Python written in C that is considered, let's say, the standard. This is the standard. It's not the only one. If you can go here and search for something called, for example, PyPy. This is a completely different implementation of Python that is meant to be fast. It's optimized. They have a lot of trickery behind to make a very, very fast, or almost as fast as C version of Python. This is a completely different implementation. So they took the same book to implement a different program on top. But the people who create Python, they have to come up with a standard, let's say, with a first implementation. Okay, this is, at least should be like this. And that's what you download here. You get this, Python 3.7, and you can download this for Windows, Linux, Mac. If you want to have the official one, this is okay. You can get it, and you will have the Python interpreter plus the standard library in one package. It's different from some other packages, like those that we will show you tomorrow. They are created by a different set of people. They are not created by the people who create Python. Some of them are really high quality, NumPy, SciPy, those are very good created for people who do science, who knows what they are doing, optimize those things. But those packages are not part of the standard library. So if you don't install them with pip, install NumPy, pip, install SciPy, you will not get them. So that's one thing. So go here into documentation, dealing with this. And here is, okay, this is for the language. So it's just the language. And this is a mistake. Oh, what is? Yeah, this is the Python standard library. So this is a whole set of packages for a variety of purposes. So you see, I will show you a little bit where they are and what they do for those that I select for you. I was selecting, this one is interesting, but it will be too much for me to show you, but keep an eye on this one. For people who is manipulating strings, not all of you are in that business. Regular expressions are important, but it's quite a big topic, so I will skip that. I mentioned that you cannot rely on the ordering of dictionaries. If you want something that is a dictionary with the keys ordered in a specific sequence, you have to use something like this. They have an order dict here, an object that creates a dictionary where the keys preserve the order. That's something. I will not mention about that. I will mention about this one, the math and the CMath for those who work with complex numbers. those are the basic mathematical equations or functions. There are a few others in the numerics. I skip most of them because people probably is happy with floating point numbers. But for people who is interested in fractions, there is one just for fractions where 3/2 is 3/2. And they keep it as a fraction. They will not make any, and after you can operate with those things. So getting a perfect result, preferred fraction. Random, I skip it because what I want to show from random will be from NumPy, so it's okay. Some basic statistics, again, I can get those from NumPy, so I skip them. So this one is interesting, the ITER tools. For some people who do combinatorics, for example, people in genomics could have interest on these kind of things, because at the end of the day, what you can get is sort of all possible combinations of these 4 letters, 5 or 4 letters for the DNA. So I skip that. I will mention this one for manipulating files. From this one, I was tempted to show a little bit the SQLite for databases. Again, not everybody is into that, I was skip it. But those are ways of storing data in more or less compact way. So instead of using one of those, I select JSON because I found more interesting to show that. Those are for manipulating compressed files. You can open and close files that are compressed directly like that, without having to uncompress them and manipulate them and compress them at the end of it. So they look like files, and you can open them and close them directly. And some of them are too much for system administrators, so I will skip those. Argparse, I show you a little bit of Argparse this morning for this example where you can take arguments from the command line, is this package here. OS, we will talk about this. And I will talk a little bit about this multiprocessing and the subprocess. There are those that you can use if you want to parallelize operations with Python, to run Python in parallel. The basic machinery for doing that are those. And here, for example, networking, I skip those things. They're in JSON. JSON is that I will use for showing you how you can store data in a format that resembles a lot like a dictionary, looks like a dictionary. So it's if you become familiar with the idea of Python dictionaries, this is really the way to go for storing data. Relatively small amount of data. By relatively small amount of data, it means a few thousand entries where you store them in a few 100 megabytes of data. This is my definition of small data. A few megabytes, hundreds of megabytes of data. XML, I will skip that thing. XML, those are for people working with internet protocols, multimedia. Nothing that is actually related to too much with science. I skip. They will mention this sys a little bit. You see, there are too many. And I focus just on those that are really into science. But use this as a reference if you search for something that is not among the list that I will present you today. So this is the second one. So this is my selection of packages, of modules that I will show you today. We'll start with this one. This one is not exactly for science, but you use it a lot for a couple of reasons. One is because at some point you would like to know the version of Python that you are using. Especially if you are writing more complex code that is not for you, but somebody else. So you know to check if they are using the right version of Python and sending a message, oh, I'm sorry, but I never intended this code to work with Python too. So This is one way of extracting specific information and saying, for example, let me see if I can do this right here. If I will execute this, this is version info.major is less than 3. And you saw that you never got that message because I'm working in Python 3. That's the reason why I include. And there is another reason. When you start working with large numerical processing, at some point you need to be careful about, for different machines, which is the precision that you can attain for real numbers. So this one will tell you what is the maximum number that you can achieve with real numbers. And there is actually an even better thing, the epsilon of machine, the epsilon. This is an important number in computing, programming. This is the closest number to 1, greater than 1, that is not 1. That's the definition of epsilon. And that depends from machine to machine. So it says that the best that you can do to differentiate 1 from the next real number that the machine is able to represent, the difference is this, between 1 and the next one. That's the epsilon of machine. So this will tell you for that machine where you're running, what is the result, what is the value for that.
Can you set that?
What?
Can you set that?
That's hardware. That's hardware. What happens is, for example, you are working with this code in our cluster, but you got lucky and you got access to an IBM machine that runs a different processors or different hardware. They will probably give you a different value for this.
Doesn't Mathematica bend those rules somehow?
What? Mathematica knows this thing, but it's able to play tricks with that. And actually, you can do this with the special libraries. There are libraries for some people who need numbers with arbitrary precision. So you can do operations where I decide that I will have my floating point numbers, or my numbers, up to 1,000 decimals of precision. So I have to use specialized libraries for dealing with that. For those, the epsilon will be arbitrary. You can decide how many digits do you want to preserve. It will be 1,000, 2,000, 3,000. It's able to deal with that, and the epsilon will change accordingly with that. Normally, with double precision, with the kind of variables that we are dealing with, no, those are constants, considered universal constants for this machine. And in particular, you can get one of those, the maximum number that you can get. So that means that the machine is assuming that floating point number in double precision. So it has this. Something similar for the integers. We can see this. And something like this. This is why I can show you now this. Remember that I told you that the range is just like a tiny machine that produces new numbers? So it's actually very small, and this gives me a perfect opportunity to show exactly what it is. let's create just a range of 1 million from 0 to 1 million minus 9, minus 1. And I can use this get size of 48 bytes. So the range is not actually the list of numbers. It's just a promise of I enable with this. If you ask me, I can give you the next one, next one, next one, next one. No problem. This is different if I actually create explicit list. I create explicit list and is what? 9 megabytes of number. That's why if you can, you try to use range instead of the explicit list from range. Except if you use this over and over, it will come with an overhead to just having that generated over and over. In particular when those iterators are complex. So you don't do that. In that case, yes, if the size is reasonable, you can just have one instance and use it over and over in your execution. So know this, that this is important, and this is a good function for this kind of simple objects to get the size of them. Lists, dictionaries, this kind. However, it will not work for complex structure like classes, where you have a class and this class has some objects, and those objects, some of them are shared, some of them are per class, per object, and you have to dig into the whole thing to get that. So there is a link with a recipe that is too complex right now for me just to dig into that. But just to know that there is a recipe if you want to collect the actual size of a complex object in Python. This is also important. And really is more important today because now you see from the last week, I show you like what? You can get Python from multiple ways. You have the Python that is installed on Spruce, for example, plus the Python that you can load through via modules. And you can also get Python via Conda and load in a specific environment for Conda. You can also, I never show that, you can create virtual environments in Python. I would like to show you that. I forgot to make virtual environments, another thing. So, which Python are you, where are the libraries and libraries that I'm using? Yes?
Google also can give us Python, like a Jupyter on Google account. I'm just logging here, it's called Collab.
I didn't know that one.
It's very nice.
Okay. So you see, now the problem now is that Python appears up to even in the soup. So there are many ways to get Python working on that, and this syspad will tell you exactly where Python is looking for libraries for things. So in my case, when I execute this, well, I was doing this on my Mac, so I was probably, yeah. You see that the paths are really bad. But if I execute this, you see that this is using some, probably this is running on a Conda environment. So it's telling me that those are the locations where, when I try to import some module, is where they try to find those. And I can add your own. You can add your own if you set a variable, not here, but on a terminal. See if I can get a terminal here. So you can decide with this variable. Something like that. A location, a personal location with you can add that to search for code in your for Python libraries for you. So this is more for developers. They set up this variable this way, but just for you to know that there are several ways. So when you execute this, you know where those libraries come from, what they are searching for. This is actually the location where Python was installed on the first place. This is Python that I'm running right now. So this will not work here, or will not produce the result that you want from the Jupyter notebook. But this is a very dirty, but still used way to capture data from the command line using the C, the RP. This is exactly the way you capture from C, the C programming. So this is the, let's say, the ugly way. If you want to do this professionally, you use ArcParse, another module that I show you in the list of modules in the standard library. So, but from time to time, for people who is just beginning on this and you saw their code, you probably see these kind of things from the capturing from the command line. Those are the main things that I use sys for. Capturing a little bit of the environment, know where my Python is, I'm reading my Python from, and eventually this one. So first one, math and CMath. Those are the libraries for computing the basic functions. It's actually the same functions that you can compute with C programming, in C language. You can do it here with the math. So it's basically the math library. The library that you use when you compile with LM, that math library. And there are two. There is this one, math, and CMath for complex numbers. They are separate. For example, if you can load this, you can get this, and actually, notice that the answer for some of those functions, and sometimes in Python doesn't matter too much, but for some of those functions, the answer is an integer. So the CL is not 3.0, it's an integer, 3. So not super important in this kind of languages, but just for you to know. This one returns a floating point number. And it's different from this one, from the ABS, that this is part of the language. The ABS is part of the language. You don't need any special library to compute the absolute value. This one works, well, okay, first, this one works for complex numbers. So you can get what we understand as the magnitude of a complex number. But it works, let me see what I have here. If I execute this, returns an integer. But this one returns a floating point number. So fabs is the floating point version of the absolute value, even if you enter with a integer. A small detail, but it's good to clarify that. Another one that I use for some certain things is the greatest common divisor. Operations where I use this is right there. Square roots. So notice that the library is different. Here I'm using the math. Here I'm using the CMath. Because if I use this one, I got it. In some other languages, that is transparent. You don't have to worry about that.
I'm sorry, what is the J for?
The J4 means that the answer, the square root of a negative number is not in the real, it's not a real number, it's a complex number, and this is the imaginary part. So it's saying that the answer for this in the complex, in the field of the complex, is 16, the square root of -1, or imagine. Yeah.
Does it mean that the CMath is specific for complex numbers and the normal math is just for real numbers?
Yes. Okay. Yes. That's the idea. The point is that in some languages you don't have to worry about that, and probably, for example, MATLAB or Mathematica, they convert that directly, so you don't have to worry about if the answer goes into the complex, it will make the conversion transparently for you, but not Python, not Python. So here I'm using this for computing the cosinus. This is pretty normal, you know, when you start dealing with numbers, getting these kind of things, simply because that number cannot be represented. This number 0.5 can be represented perfectly in floating point numbers, but the operations that this is doing, the math is doing, that is actually solving a series that converts to cosinus, collects one of few bits that give you that one at the area. So this is wrong. This is not much of a problem for most cases. You don't have to worry about that. For some other cases, there are compensating ways of manipulate such that those errors doesn't sum up, doesn't grow. But those are exotic. So you can again, with the CMath, you can compute the cosinus of a complex number. So I'm basically showing there that the cosinus in complex of this purely imaginary number is a purely real number. That works. So why I'm probably not too much interested in math for some purposes is that NumPy is able to do this for arrays. And most of the time, but the kind of things that you would like to do are for vectors, for arrays of numbers. So if they contain the same thing, I don't see too much reason to deal directly with those. And the NumPy version, so the NumPy version of these libraries are able to deal with numbers the same way. So complex numbers. So that's good. But it's good for you to know that this exists, and for some operations, it's simple enough, and you can work with that. Okay. So OS and OS path, they receive those two names, but they are separate modules. At least how they are organized in the standard library. Understand OS as operations that are related to knowing about the operating system. And OS is operations that are related to locations in a file system. So in the tree of files, folders, dealing with those things. So those are kind of separate things in the way you understand. And actually here, they are in different sections in the standard library. This is extremely used. Probably I would say 90% of the time I am always importing this library. OS. Why? Because for example, I would like to create folders and storing my data on different folders. So I need to use OS to create those folders. This is, for a lot of functionality, is basically replacing exactly the same things that we show you when we are dealing with the command line interface, how to create files, how to create folders, how to remove, copy, move, all those things. All those things you can do with this module directly from Python. So important. One is this one. It's not actually telling me the operating system per se, but it will tell you that this system is POSIX compatible, so it makes like it's like Unix, or is Windows, or whatever. And those, for those who attend the HPC last week, there are a set of variables that are called environment variables, that collection of variables that the system uses for different purposes during execution. All those are here in this environment. So you can get, for example, which is the shell. I mentioned the terminal. The path should be around here. Where is path? Here is path. Where to search for executables in my environment. So you notice that this is very related to the operating system that you are using. And if you want to use which user are you right now on this Jupyter notebook, you get something like this. You can execute this to get one specific environment variable out of this. This is the equivalent, and that's why I'm putting these comments on top of that. So we will deal with a few of those functions that has an equivalent in the command line interface. So this one is the equivalent of pwd to get my current working directory. Now it's this one. This one, and I actually add this because before, when I execute this, for some reason I keep the dictionary making an error. So pay attention to this. This one is just creating, and we will see in a minute what this is. This one is creating a folder with a. This is exactly the same as last week NKD. Same thing. This one is exactly the same as change directory. Change directory, you can use the two dots, the same things that you used to, except for if you want, for example, to do something like this. Let me see. This will not work. And this probably is obvious, but you cannot do this. Of course, but you can do something like this. To get the same effect. So you capture the environment variable for home, for your home, or if you are working with your account, if you have a normal account on Spruce, you can use a Scratch and move to a Scratch and do something with that, and change, and is this. You can list the contents of a folder. Let me see what they can do. Okay. What is the content of a folder? And let me see what I can do with this. You see the files and data that I'm been creating with this. One thing that I use a lot is, and we'll see this, it's a list comprehension. And let's say that I would like to see all the Python notebooks. This is a list comprehension that I use very often. Or directories. Let's see if I can get another here. If this is related to something that we showed us, is the checking if something is a directory and getting that directory. Those are directories. Those are folders. How I use this? Imagine that I have my research. I have a lot of directories with directories inside. So with a few command lines like this, I can create a script that is basically recursively digging into the whole structure file, searching for data, like a scavenger, all that we like to use and collect. Basically with that. So if it's a folder, enter in that folder and do the same function. If it's a file, see if I can get the data that I need to process and move. So this is something that I use frequently. Here to remove folders. And this one. This one, okay. This is one way. There are several. Subprocess offers something similar to this, to know how many cores are available on a system. Those are not necessarily the number of cores that are available to you. And as you mentioned last time for the HPC, those in HPC, those are completely different things. You can submit a job when you request 6 cores. But you can get a machine with 16. If you are not careful with this, you can eventually create more threads that actually cores that are available to you. If you are using a spruce, you're probably screwing somebody else, or you are screwing yourself, creating more cores, creating an execution that exceeds your abilities. Yes?
Is this when a command does physical cores?
Physical cores. That's why this is not what you're supposed to use. But what you're supposed to use, and this is not available on Mac. Some operating systems are available. I'll give you that. Some others not. Let me see if I can get that for you here. Maybe this is a Linux machine, so it should be. This one. Okay, what's that? This in machine. Okay, there are several things that I probably mentioned that. Okay, I have to divert a little bit. Modern computers, computers like those in the cluster, they have multiple processors on the same node. For example, we have the machines. Spruce typically have 2 processors. Those machines with 16 cores have 1 processor with 8 cores, another processor with 8 cores, total 16. And those modern machines have something that is called NUMA. That means that even if this processor has access to the entire memory, all the modules, all the memory modules on that node, and this one has access to the entire memory of that node, the speed how this processor accesses the memory depends on which location of the memory. So there is some memory that is close to this machine, there is memory that is close to this machine. Accessing to that memory is really fast, accessing machine that is in the other side of its environment cause some penalty in terms of time. So what happens is the operating systems start developing what is called affinity. That's one way of understanding affinity, is that they try to map memory only that is close to the processor and not putting memory in locations that are topologically too far. That's one way. Another one is that, for example, on Thorny Flat, on some machines, so for example, in this kind of machine that is probably running, we have 6 cores, but this is a virtual machine that is running probably in a machine with 16, 20, 30 cores, I don't know. They can fix what is called affinity, meaning that a specific process can only use this core and this core and this core. Even if they are, other cores are idle, it will not touch it. It will not start sending processing to that cores. So what this is actually telling me is, for me, for this process, which cores of those 6 that I have available on this virtual machine, I have access. I can process on them. On Tony Flat, what happens is that there is something called C groups enabled on that machine. So if you receive a machine, but you request just 2 cores, and you start creating threads of multiple processes, those processes are screwing to those 2 cores. They will be sharing one forum thread, one other forum thread, but you will not start expanding and squishing the other process from your neighbor. So that's one way, but again, this is something that is enabled in Linux machines, but in Mac they don't tell you this kind of thing. So that's how you actually, in real coding for HPC, you should actually get in the number of cores that you have access for your execution.
So you have access to all of them.
So that means that right now I have access to all of them. So all of us is sharing the same machine. All of us is actually using those 6 cores. The advantage is that not everybody is executing heavy things at the same time, so we are fine. But
so we are running something on a remote computer.
On a remote computer. When you're executing, all of us.
When it's on Jupyter, it's not using my computer.
No, it's not using your computer. It's using a computer that in Indiana they offer us that, or when you are using a Spruce and you run this Jupyter notebook, it's running on that machine. That's the good thing. That's the nice thing. Basically what you want is a workstation. You sit there and you work, not realizing that you are not using your machine. You are using somebody else's machine. So a different machine. You are processing and you're getting 16 cores. You probably don't have 16 cores, but I don't know. Some of those new Macs probably have those. But yeah, you don't have as many cores as normal.
So when I run Jupyter, I can ask for more cores before running.
You can do those things with some other thing that is available in not Jupyter Notebook, but it's something, another thing that we used to be part of IPython that now is called IPyParallel, that allow you to create workers, and those workers can execute parallel executions even in different machines. So you can actually do distributed computing, multi-processing using all codes available on different machines. But though this is the kind of advanced stuff.
So is there a way to do the same thing for GPUs? Similar.
GPUs will not operate like CPUs. Those are different things. What you can use is to hire something, for example, using PyCUDA, or if you are using TensorFlow, they interact with the CUDA, with the GPUs, let's say, transparently. That is something that at this level, the standard library will not give you that kind of property. No. It's nothing that you can do with it. This is something that people who started writing the scripts, making this mistake or this awful coding, is doing this. So I know one of you professors who do this kind of algorithm. Please don't do that. There are a good function. What is this? This one that do exactly the same thing. So people used to execute this kind of thing. But it's not recommended. It's not a good. It's actually you are creating the small overhead. Yes, that is not. It's not. It's more aesthetics, but than actual operative. It is adding some extra overhead because you are creating a subshell to execute one simple command to get just one directed mode. But and this one is not creating those extra shells, subshells, or is paths. This is exactly what I use here to check if something exists, if a directory exists. Because otherwise, if I execute this, see, so every single time that you try to create a folder, it's a good idea to add this small trick to check if the folder exists and create it. For files, this is not a big issue, but for folders, you will look at that. There are different kinds of files. Directory is a file. In Unix terminology, it's like a file. So one thing is to know if something exists. Another one is to check if something is a file. This actually is not a very good idea in some cases when you don't have control. Because one thing is that, well, not here. Here is a good thing. See, if it doesn't exist, you can create a folder. But you cannot use this one where you are checking that if something is a directory and try to create a folder. Because if something is not a directory, but it's a file with exactly the same name, you get into the same trouble. You're trying to create a folder for something that already exists, a file with that name. So this is a more granular way of checking for existence of a file, existence of a directory. This is what I showed you a few minutes ago, how I use this with list comprehension to get the list of files or the list of folders on that group and on that folder so that I can recursively enter inside those folders and those folders and those folders. I use it very often. For example, I can use this together with another library that gives me checksums of files in order to search for duplicates in my files. So big files that are duplicated, I can use this kind of procedure recursively searching the whole file system structure for files. This one is good. This one will tell me from a folder that exists, what is the absolute path to that folder. So the full path. Sometimes you don't want to use the full path if you are moving this from one place to another, because that way you are breaking the whole code. So it's better to use relative paths if you are working with something that you control and you move as a whole. In some other cases, you want the full path to control where exactly things are okay. And this one is good. It's interesting. You can split a folder or file, and if you know that something is a file and you get something like this, you can split it into the folders and the file name. But notice that if this is a folder, it will tell me the name of the last folder and all the absolute path up to that folder. So it's slightly different in some other languages. Well, it's actually different how the shell works for this kind of purpose. So basically, this is the idea is that it takes this, it searches for the last separator, is this, and and it will put this as the initial port, and it will put this as the final port. There is another thing that people in Windows, because you can do this in Windows, the paths will be different, but there is something that you can use here, and is know what is the separator used in that particular operating system. If you want to create something that works good in Linux and works good in Windows, instead of adding those slash that only works in Unix environments, use this. This general makes your code can operate with Windows and Linux nicely. So this is so in Windows. When I don't have a Windows, I check this right now. It will just the backslash. Okay. And notice that all those things that we did here in OS operate just with one file or one folder. It's just one thing. But sometimes you want to do a more powerful operation with multiple things, or being closer to the kind of things that you can do with the command cp, mv, with multiple inputs. Moving several files into a folder, that kind of thing. And this module is for that. Consider this a high-level operating system machinery for moving files. In particular, I use this one. This one I use often. In this case, I'm moving this, could be a file, into this that is a folder. You cannot do this. This is actually replacing knowing that I'm putting the file in the test folder, new file 1. So this knows that, okay, this is a folder. I will put this file inside that folder. There are some others in this section that allow you to preserve the permissions and ownership of files when you copy them, when you move them. That preservation of properties is not fully implemented. It depends. So there are let's say extended attributes, that's how they are called. So they are in Unix environments, and those are typically not propagated when you are doing this kind of code. But the normal users, ownerships, permissions, yes, they are propagated. So with this kind of functions. Okay, so I use basically SHUtil for this.
Can I?
Yes.
Can I have a command that shows the operating system?
What do you mean?
Which operating system is running?
Well, it's, let me see. Okay.
And the return positives, right?
Yeah, it returns POSIX, but let me see. Let me see if I get something else that is more specific. You see, what I did was, okay, trying to figure it out from the name, because I will not read right now. I put OS dot and hit tab in order to search for something that tell me something that could tell me the well, maybe it is your name. Let me see. Well, this one is good enough. This is actually the same that executing on the command line. Again, this is not Python. This is the notebook that allow me to do this. From the command line, I can execute this and know, for example, which Linux, it's Linux, This is running cloud environment. This is the name of the machine of that cloud environment. This is the version of the kernel. So you see it's actually telling the name of the machine, the kernel. So it's not actually the version of Linux, but the version of the kernel. Well, here it's telling that it's an Ubuntu. So it's a virtual machine with an Ubuntu that Nate create for this training. So it's a Ubuntu machine, and it's running on 64 bits. So yeah, that's. So when I see that, you asked me about the operating system. The first thing that came to my mind, okay, this is something that should be in OS. And after that, you can search in the standard library for something around that do what I want. Okay, so OS. ITER tools. ITER tool is powerful for people who is dealing with combinatorics, permutations, these sort of things. You need to get used to work with expanding those things without having the full knowledge of the list that will be created, that should be created for extended list. Let me elaborate on that. ITER tools, most of probably everything in ITER tools, what they create are iterators. Again, this tiny little machine that produces new elements every single time that I ask for. This one of the simplest. You start with a certain value, and this iterator will produce infinite numbers until the limit of an integer, starting from a certain value. So as they will produce infinite numbers, I cannot use to iterate on all of them, or the machine will collapse. So I put a different index here, and I'm basically stopping this if the index crosses a certain limit. 9 iterations. So what it does is this number start with 13, 14, 1, 10, and we'll iterate. Yeah, I forgot this. So the same thing if I want to stop it when I reach 99 elements, it will produce new elements forever. This count. Okay, this is one. Another one. This is something that I use later, you will see what I am creating plots. Why? Because I would like to have plots. I would like someone who reads my paper not be confined to read it just if they have a color printer. So I have to do 2 things. One, make the lines with different colors, so someone who printed in colors is nice, visible, but also with different symbols, such as people who print this in black and white can differentiate from the symbols, and just from then see what I'm referring to with the legend. So this triangle down is doing this, is showing this, the triangle up is doing this, the triangle moving to the left, to the right. So this cycle help me to produce different symbols recursively. And so I can produce them with different colors, with different symbols, in such a way that I get a variety of different lines in my plots. So basically, this is taking an iterable, like a string, and it's producing first A, E, O, U. It will repeat and repeat forever. So again, if I execute this for a sufficiently large number, you notice that it will go all the way and recovering again the same sequence of numbers over and over, same sequence of characters. So when you see this in Matplotlib tomorrow, you will see that I have something R, G, E, K for black. So I can change and I can operate with this and make different lines, one with red, one with blue, and if the colors are exhausted, I can recreate new ones. So that's why I use this cycle. I don't remember how I use it for anything now. Okay, this one. When you need a certain number of instances of the same thing. I can create this, let's see, let me see like this. So this is one way. For such a small thing, I can do exactly the same, doing this. So this one will be exactly the same as, remember, this is an iterator, so this is not a list. If I want the list, I have to ask that to be explicit and be converted into a list. So iter tools work for that. I actually did it. Permutations. Here, I have an iterable. It's a string. So this has 4 elements, 4 characters. And I'm asking for all permutations of this in tuples of 3. So you will see that I have this element. So order matters. This ABD should be here. But as order matters, this is a different thing. Right? Let me see. Yeah, okay. This is when you need permutations. Again, this is an iterator. It will not show you all those elements. If you try to do this, it will not work. Let's see. This is an iterator. They will give you just this. You want the whole list as a list, well, you have to expand. And it will become a list. There is not a specific ordering for this, as far as I know, except for the algorithm that produces the elements, how that was coded. I don't know exactly what was the algorithm for that, doing that. So you cannot rely on any specific order for those permutations. Combinations is the similar thing, but this time the order doesn't matter. The combinations of the same thing. So the same question for combinations, just those 4 elements. And this one is the dot product. This one, probably I use more often this one, because this one is basically like taking from the set of these 4 elements, 4 elements, 4 elements, and 4 elements. I'm taking one of here, one of here, one of here. Or at least in this repetition two times. So I'm getting this, I'm getting this. Okay. There are more things in these iter tools that I do not use as really often. This one is interesting. JSON. And actually this one, I have a few exercises are related to this one in some extent. Some people store data like tables. Imagine that you want to store name, gender, age, things like that. One way, yes, is storing that, like those tables and try to collect later the data for that. There are better ways from doing that. One of those is using JSON. First, JSON is a standard. This is a good thing. So you are not using any proprietary format that will be obscure, and in 10, 20 years from now, no code is able to read that thing. Another one is that is part of the software, comes from Java, so from JavaScript, another language is often used in web interfaces and web applications. So if you at some point envision that your data could be processed to make nice visualizations like those, for example, this is in JSON. So P3GS is a nice thing. Later you want to do things like this with the data that is behind that is in JSON. It's JSON. So it's a good idea to a good format for storing data. Another thing is that it looks a lot like a Python dictionary for a few small details. So it resembles a Python dictionary. Another thing is better readable than XML. You know those XML with those tags here, tags here, tags here, tags here. At the end, you see more tags than actual data. So it's not a very readable format for a human. It's very nice for a computer, but for a human, it's not very readable. JSON files are very readable for a human. They look like dictionaries. So here I'm showing you how that looks like. So this is a Python dictionary. I'm creating a Python dictionary here, a small one. And I asking this JSON module to give me a string representation of that Python dictionary. Just a string. With this, notice that this is no longer a dictionary. This is a character, it's a string. But this string, I can reconvert it back into a dictionary. And Python is able to make that conversion really, really quickly, efficiently. And there is another version of, not in the JSON, not this JSON, there is another, I think it's called CJSON or something, that is even faster than this one for really large data. So it's able to parse this data super efficient. Let's play a little bit with this. So you have this is a string, and I'm using this string again to recover my data. In my example, I will have something like this, with my example with names, gender, age, and things like that. I will have a list. Name, and it's a dictionary, so several dictionaries. Name, this one. Age, that. Day of birth, this. Gender, that. So I will collect all that information. Another thing, the metadata, so the information about the data will be with the data. With a table, if you don't put something on the very top and saying these are the columns, you're lost. So it's a good idea. It's a good idea. JSON is a pretty good idea to store data. If you are dealing with extremely large amount of numbers, this is not a good solution. A good solution will be something like HDF5. I told you about that last week, to store really massive amounts of numbers. But for these kind of things, is perfect solution. probably better than actually saving in CSV files, actually, except for you cannot read them from Excel. But if you can survive without Excel in your life, well, probably this is better. If not, CSV files. Anyway. And you can do these kind of things. You can pretty print, let's say, print those strings with new lines in such a way that you can read them nicely. So it's even more readable. And at the end, they will look like how it that was here. I will show you this. That some of the things that I collect was from here. This is a place where they have data sets for a variety of things. I will show you some of you about this. Let's see if I get this. So, and they have data here, and often, for example, this is atmospheric carbon dioxide in the so the trends data. Of course, those are seasonal things. But here you see that you can get this data in CSV file. For those of you that have to rely on Excel files, something like that, or JSON. And the JSON file, this looks like this. And you can pre-print it, so you can get those like sections with this. Let me see if I can, yeah. And get this data nicely in columns. So it's the same thing. Some of those. You got it. So this couple of functions, those that end with S, is to convert a dictionary into a JSON string, and from the string into a dictionary or list of dictionary. There are equivalent versions of that without the S, where you store the data into a file, into something that has a write on read. Even better, you can open a file that is actually a compressed file and read all this JSON from a compressed file, or you can dump this data back into a compressed file. You can do that kind of thing with Python. Otherwise, yeah, you can do it in a text file, and after compress the text file, and when you want to use it uncompressed, and you don't have really to do that with Python. Okay. And if, for those of you just missing, I should. There is also a CSV file equivalent for that, in case that you have to rely on the CSV files. So you want to download this and you want to play with this CSV file. I'm not showing this because tomorrow we will use pandas, and pandas do this naturally with the JSON and the CSV files and some other files. And so for data analysis, if you want to be in data mining or things like that, pandas is much better solution for that than actually using those standard libraries. So process. This has been one of those things that have changed across the lifetime of Python with the years. I will show you what I typically use, because those things have changed, and it's this, popen. I prefer to use popen. Nowadays, people, instead of this, use run from Python 3.5. Run is available. And before Python 3.5, people use something, the function was called call. So I don't like those changes that much on my code. And so I went in, okay, I decided, okay, let's use popen. Popen has been around and is lower level library function for doing that, but for me it's okay. This library provides the ability to launch processes that are not part of Python. If you want to execute something and you just want this to be executed, like typing that on a command line, this is the command for doing that. So basically what you do is executing this. This is one way. This is one way of executing this. You can so basically here you are encoding the commands that you would like to use for doing that. I will show you another way. That is a little bit dangerous, but it's what I use more often. And this is to store the standard. There are two things when you execute any command on Linux or Unix environment: the standard output and the standard error. Those are different pipes or different ways of collecting data, move data. Some commands write things in the standard output. Some commands write even things that are not actual errors in the standard error. So here I'm piping those here. And after I executed this command, the command will execute. When they finish, they will send me the final result. And with this communicate, I can capture the output. And the output will be in a string, so I'm capturing this. It's a little bit more you have to do 3-4 steps to achieve that. And the other way is with call. I'm not use this so often, but let me see if I can get subprocess.run. And typically I work like this on this and CLS. This is another way. Yes, you see, I never use this one. Let me see. From Python 3.5. Run. Oh, yeah, of course. Where's my mistake? I forgot to put this live in. This one should be. Yeah. So you see, you got a string here when you execute this command. And when you print this, you will see the new lines. Oh. Like that. It's a pain. that because this is, when you execute this, what you get is a byte string. You see this with this B. So it's not actually a string. It's a byte string. This is in Python 3. So you have to code so equal into a string in order to be able to see this. So for example, you can have some, like one command that executes, and it will take some time to execute. You can use this kind, actually you can use this one. This one will execute immediately. This one is actually better because you can create several processes. For example, they are doing a simulation or they are having to do some molecular dynamics and they will take a few minutes to achieve. So you can run several of them and collect data, prepare some others and running. So you can run in those things multiple times. This one for this one. Okay, the final is this multiprocessing. There are several libraries for dealing with parallelism in Python. There are some other that are not in the standard library, so that allow you to execute things in parallel. But here there are basically multiprocessing and multithread. For real crunching numbers, multithreading is not the way. It's not the library that you should be using. Forget about multithread. The good library is multiprocess. You are actually creating several processes that run independently and execute your job concurrently. So imagine that you have a database with thousands of pages. And if you are able to divide that work such that several cores work with the data independently in a divide and conquer way, with a few commands, you can achieve this with multiprocessing. And I will show you the easiest way of doing that kind of thing. So multiprocessing here. And here I am, for example, creating this function here. This is one function. And I'm using math here. So and I am computing the cosinus function. Well, the function itself is not very complex. But I imagine that this could be a very complex function that takes several minutes to compute, or you have even to take some data and manipulate some data somehow. So the meaning of this function is up to you. What I would like to do is to create a pool of workers, slaves, workers for me. And I'm selecting here, because I was preparing this on a Mac when I don't have this CPU affinity, counting the number of cores. In this machine will be the same. It will give me 6. So I actually can test. I'm getting 6 cores to work with this. So basically what it will happen here is that I would like to do this for 100 elements. So they will divide the work for those 6 cores, and each one of them will execute the function. And when they collect all the results, they will produce the output. All the cores will be working. I'm not doing this for a real large thing, because if all of you will start doing this, we will eventually saturate the machine, but I will do it for them small. But the point is, you are dividing a work that used to happen for 100 cores, or 100 elements into 6 cores. They are working together to give you the result. And you see that it's really simple. It's just the creation of this pool and mapping a function to an iterable. So let me see if I can do this. Well, in that case, I have to be. Which one we can? Well, this is it. Okay, let's do a few changes here. I will be executing this one. Or in this one. And we move to the exercise. And okay, I was a little bit silly. So basically, I'm here and I'm executing this. Yeah, pretty fast. So I'm executing a slightly more complex function is the complex cosinus. And here I'm doing this for 10,000 elements. So I am dividing this execution. All of them are exactly doing the same thing. They are dividing this in 6 cores. All of them will work for a few seconds and produce the result. There are some other things that you can do with multiprocessing. I want to mention now. Sometimes I never use actually the pool for these kind of things, yes, but where you have several workers, but some of them will devote it for some workloads, and I reserve some of others for other workloads, where they are depending on the outcome that is producing from the first one. So I have 16 cores, and I can devote 10 for doing some crunching numbers, and 6 that will after process the results of the first, what is being produced for the first 10. And that way I am balancing the whole execution in my process, on my node. Okay. And I mentioned here the get affinity. Okay. I prefer to keep it simple and just showing just a few modules for you. And so you can move into the exercise here, exercises. So one of them is using the math and CMath to compute this equation for 20 numbers. A small thing, just for you to see that how you import, create a list of values, and execute this. Things will become more interesting when you move to NumPys and Matplotlib and things like that. And this other exercise is a JSON file. It's a JSON file that you have right here on this one. Actually, look, yeah, Python is able to, the Jupyter Notebook is able to show me the JSON file. So see that this is a very easy to read format for data, readable. It basically contains for countries or set of countries data about the population, actual or I think it's population. Yeah, this is for us conglomerate of countries actually. From the 60s to 2000 something, 2010 I think. Yeah, 2010. So from this JSON file, I would like you to load the file. So you don't have to download anything, the file will be there. So you just need to load this with the, and actually can show you that. Import. So let me see if I have it here. Okay. So you will have the opportunity to move into the folder. I will do it not using the command, so you will start doing this for real. So this is not Python. I would like to take the syscom population. You have to do this. This is how you open a file in Python. I never actually showed that this morning. And you get the whole data. And from there you can start answering the question, right? So you would have to dig into the different values of that dictionary. So again, is playing with that and collecting the population in 1980, population in 2000, get the relative difference and see which is the country that have seen growth in population the highest for that. And this one is more, number 4 is more for playing with the folders, opening folders, checking if the folder exists or not, creating new folders and storing the data or for that country on an independent folder. So this is second problem. Third problem. This one is a little bit tricky. Let me see. I never put the question.
You have to close these files after you open them.
What?
So you should opening that file. You have to close it afterwards. It's like a pipe.
Yes. Yeah. Well, you don't have to, but yeah, it should. Let me see. Let me show you this really quick. So. Okay. So you close this file like this. This is how you close. There is another more Pythonic way of doing this. And operating this way. And the file will be automatically closed at the end of this operation. So this is another way of doing this. And you don't have to worry for closing the file. Both ways should produce the same result. So this is for the second one.
And for this one, is to compare, the idea was to compare try to extract the expenditure for the United States. I forgot to mention. Or eventually compare with some other countries. So again, it's extracting the data. Tomorrow we will see, so you can start working on those exercises, relatively small. We will start looking at NumPy for crunching numbers. It's not that hard, NumPy, once you have started using it. SciPy will do something similar to what they did for the standard library. A few of the things that you can do with the different modules in SciPy. SciPy allow you to do, for example, integration, regressions, interpolation at this point, special functions, bezels, or that kind of stuff. And Matplotlib. Matplotlib, I will try to focus on you create plots, how you change those plots for publication, and Pandas. Pandas is something that I will put some effort for. Okay. To complete this, to write a file is also similar. I can this is how you write a file. So for that exercise where you are writing data, open and closing files, open files. This is my name. This is my, I used to do this to know for me that the file is for writing or for reading or for writing or for reading. This is me. But this is how you have to open it for writing. This is how you do it for reading.
I think so. Found another one.
Can't figure out how to dial this down into so so you want to go to the wall. So one way of doing that is, for example, you can connect them some country codes, for example. So it's a country codes. This that's research. And check if there's a key that they so code. So you see, so you first you collect all possible country codes.
Yeah.
And then you use. And after you can even one way is first the country codes on one equation we started at creating orders for every single country. So from the country codes you would like to use the country codes for the country way. Or you collect is the name of the country or set of countries and you start making orders for them. And after you can start collecting in lists or in another dictionary or the list for this country, those are the value that I have for the year or for this one. So it's just manipulating the data. And that's it. For at least this is the straightforward. Yeah. I thought it was just you can
that address that specific logic. Like an argument to that is core bracket one bracket.
That's why this is okay, but this is not how you actually want to talk. Practice. Or say you want to see this as a template. Yeah, the kind of thing that you see on that Excel file. Pandas is able to load the JSON file and get able to do that. You have all those as columns there, and you can capture it directly. So pandas will do that much better. But for introducing pandas to JSON, I have to introduce this first. Tomorrow we will use JSON. That's fine. It's faster bites later because you know that for one that works. And we have to do it for all of them.
PBS management. Some use perfect.
Yeah, well, if you want, you can put your measure your surface. have it. It's fine. That was software sometimes that you would generate. So, but these they file and those two like this one. This one. See this one were created July 16th. So you see that this is what my understanding is. We execute this for all devices. Probably I would copy those. We can go run all. So I would see. Plus the sigma. So quality. All those, imagine all those prompts are inside this sigma. And this interior file is so what we will have is exactly for all. It's not that you do that much.
Oh, yeah. Yeah, we're making this up.
Are those all
I had something that
So let's yes. I don't ever see it exactly. So I think there is something scale the number of the size of the capacity.
We're trying to start with a slash.
You know the length, and I think that. So I am. Don't like whatever is what I would see what I execute this what it is which is best show you. So at the end, so yeah, it's fine. So now what you have with is yes. Check. Shipping quality with right top. Oh, sure. I know I do this. No. Any okay. What?
That's pretty. As it looks like this. Sounds wrong. It is also you should have that is set up with this.
Yes, for each of them, this is how that.
So this right here is one beneficiary, so which is the country name, country code, year, value.
This is not because it didn't be a post. That's the only reason why it's to get a browser. Get a only that.
So when I
Don't
bring
get
it right
have
up
the
through
browser that.
AAA,
That's
area through AAA, data is all their dictionary.
you can use those, but
Yeah. So you want to these guys for each iteration.
there's the one line. So the right now is
Well, the reason I needed 60 was getting 60s.
so I think that these things
Another exercise that makes sense.
this is running almost. That's yeah,
Six to do that.
the worst is
Oh, look at the system.
so it's okay.
This is
Few things fast use for everything. We are using 16 times probably possible, but it's so much. We are using 16. So it's and we are using much more now. So we are not getting so those were the huge so we're using more force. Using the lab.
there's got to be a better way.
And just to be safe. Those. Those kids, it's not underscore. I don't know what I said down.
You know, like I said, do this.
Yeah, we would have all of them. For sure, by the end of the day.
That's what you need. 2000.
That's what it is. Like,
Big one.
like this one. Only one. But for sure. In fact, you can do this a couple of minutes. And you can see an arm. You see an arm here.
But yeah, which bumper.
And
So this takes, so 80s is a empty dictionary. So we take 80s, and whenever we're making a new dictionary, we're making entry dictionary. And we put it here is what we want to call the rest keys, and rest is equals to the number one. Yeah,
he's right. He's right. Now he's right. No, they, yeah, you run. And now they all 0, 10%, 10%, jump, 10%, 10%, jump. Or I always simplify. It will be all the percentage. The price. Except if someone has.
Yeah, you can still